If you like the space and learn about its curiosities, consider subscribing to the channel. We have 2 videos every week. Thank you for your attention and enjoy the video. The vast expanse of space has always intrigued humanity, with its endless mysteries, distant worlds, and unfathomable scales. Imagine standing on a quiet beach at night, looking up at a sky filled with countless stars, each a potential window into another world, another time, another dimension. The human mind can scarcely comprehend the enormity of the universe, and yet, with every new discovery, we peel back another layer of the cosmic veil, revealing even more to wonder at. One of the most fascinating aspects of space is how little we truly know despite centuries of observation and exploration. Space, for example, is not completely empty as many imagine. While it's a near-perfect vacuum, it is filled with a variety of particles, from dust to single atoms of hydrogen floating in the vastness between stars. These particles, while sparse, can still influence cosmic events over millions of years. For instance, cosmic dust, which drifts through space like an invisible fog, can eventually gather and form planets, moons, and even life under the right conditions. Some of that dust is responsible for the meteor showers we witness every year on Earth, tiny remnants of the early solar system burning up as they enter our atmosphere. Another mind-bending fact is that space itself is expanding. It's not just the galaxies moving apart, but the very fabric of the universe stretching over time. The idea of an ever-expanding universe was first proposed by Edwin Hubble in the 1920s, when he observed that distant galaxies were moving away from us at speeds proportional to their distance. This was a groundbreaking discovery, leading to the theory of the Big Bang, which suggests that the universe began as an incredibly hot, dense point around 13.8 billion years ago. What's even more astonishing is that the rate of this expansion is accelerating due to an enigmatic force known as dark energy. Dark energy makes up about 68% of the universe, yet we still don't know what it is, only that it seems to be the driving force pushing galaxies apart. In addition to dark energy, another cosmic mystery is dark matter. This invisible substance accounts for approximately 27% of the universe. Unlike normal matter, dark matter does not interact with light, making it impossible to observe directly. We only know it exists because of its gravitational effects on galaxies and galaxy clusters. Without dark matter, galaxies would not have enough mass to stay together. They would fly apart under their own rotational speeds. In essence, dark matter acts as a cosmic glue holding much of the universe's structure in place. On a much smaller, yet equally fascinating scale, consider the stars themselves. Our own sun is just one of roughly 100 billion stars in the Milky Way galaxy, yet it is a relatively average star, both in size and temperature. Some stars, like Betelgeuse in the Orion constellation, are so massive that they make the sun seem insignificant. Betelgeuse, a red supergiant, is nearing the end of its life and could explode in a spectacular supernova within the next million years, a blink of an eye in cosmic time. When it does, it will shine brighter than the full moon and be visible even during the day, a final, fiery death before collapsing into a neutron star or black hole. Black holes themselves are another of space's most mysterious and terrifying phenomena. These regions of space are formed when massive stars collapse under their own gravity, creating a point where the gravitational pull is so strong that not even light can escape. The boundary around a black hole is called the event horizon, and anything that crosses this line is lost to the black hole's inescapable gravity. What happens inside a black hole remains one of the great unsolved mysteries of physics. Some theories suggest that black holes might even be portals to other parts of the universe or different dimensions. But for now, these ideas remain purely speculative. Closer to home, our solar system is full of surprises. Jupiter, the largest planet, has a magnetic field so strong that if you could see it from Earth, it would appear 5 times larger than the full moon. Its immense size and gravity also protect Earth from many potential asteroid impacts by pulling space debris into its orbit. Jupiter's moon, Europa, is particularly fascinating because beneath its icy surface lies a vast ocean of liquid water. Scientists believe that this ocean, kept warm by tidal forces generated by Jupiter's gravity, could harbor life. If true, it would be one of the most profound discoveries in human history. Life on another world, not on a distant exoplanet, but right here in our solar system. Mars, often called the Red Planet, has been the subject of fascination for centuries. Recent missions have revealed that it once had liquid water on its surface and a thicker atmosphere, conditions that might have supported life. Today, NASA's Perseverance rover is scouring the Martian surface, searching for signs of ancient microbial life. If we find evidence that life existed on Mars, it could suggest that life is far more common in the universe than we ever imagined. It's not just Mars and Europa that excite scientists. Saturn's moon, Enceladus, also has an underground ocean, and its geysers shoot water vapor and organic molecules into space, hinting at the possibility of life beneath its frozen exterior. As we venture further into the cosmos, we encounter exoplanets, planets orbiting stars outside our solar system. The first confirmed exoplanet was discovered in 1992, and since then, we've identified thousands more. These planets come in all shapes and sizes, from gas giants larger than Jupiter to Earth-sized worlds located in the so-called habitable zone, where conditions could allow liquid water to exist. One of the most promising candidates for habitability is Proxima b, a planet orbiting the star Proxima Centauri, just 4.24 light-years away. Although this may seem close in cosmic terms, with current technology, it would take tens of thousands of years to reach Proxima b, underscoring the vast distances that separate us from even the closest of stars. Perhaps one of the most mind-boggling concepts in space is the idea of time dilation, predicted by Einstein's theory of relativity. According to this theory, time moves more slowly in stronger gravitational fields or at higher speeds. This means that if you were to travel close to the speed of light, time would pass more slowly for you compared to someone on Earth. This bizarre phenomenon was famously illustrated in the movie Interstellar, where a crew of astronauts experiences hours on a distant planet while years pass on Earth. While this may seem like science fiction, time dilation has been experimentally verified using atomic clocks on high-speed planes and satellites. The sheer scale of the universe is equally overwhelming. The Milky Way galaxy alone spans about 100,000 light-years, and it is just one of an estimated 2 trillion galaxies in the observable universe. To put this in perspective, if you could travel at the speed of light, it would still take you 100,000 years to cross our galaxy. Even more mind-blowing is the fact that many of the stars we see in the night sky are already dead. Because light takes so long to travel across vast distances, we are seeing these stars as they were millions or even billions of years ago, a snapshot from the distant past. And then, there are the cosmic phenomena that continue to baffle scientists, such as fast radio bursts, FRBs. These are incredibly powerful pulses of radio waves that originate from outside our galaxy, lasting only milliseconds, but releasing more energy than the sun does in an entire year. Since their discovery in 2007, dozens of FRBs have been detected, but their origin remains a mystery. Some speculate they could be caused by magnetars, highly magnetic neutron stars, while others entertain more exotic possibilities, such as alien civilizations attempting to communicate. With every new discovery, space continues to surprise and challenge us. From the strange and the beautiful to the terrifying and unknown, the universe is a frontier of endless possibilities. As technology advances, so too does our capacity to explore these mysteries. Whether it's landing humans on Mars, discovering alien life, or unlocking the secrets of dark matter, the next century promises to be an exciting time for space exploration. But for now, we remain a small species on a small planet, looking up at the stars, wondering what lies beyond. As we continue to gaze into the cosmos, one of the most fascinating questions remains: are we alone in the universe? The search for extraterrestrial life is one of the driving forces behind many space missions and research projects. The discovery of planets outside our solar system, known as exoplanets, has opened a new chapter in this search. With thousands of exoplanets already identified, scientists are focusing on finding Earth-like planets in the habitable zone, where conditions might allow liquid water, a key ingredient for life as we know it. One of the most exciting discoveries in recent years is the potential for microbial life in places we never thought to look before. Take For example, Venus, which has long been considered inhospitable due to its scorching surface temperatures and crushing atmospheric pressure. However, in 2020, scientists detected phosphine gas in the upper atmosphere of Venus, a chemical that, on Earth, is associated with biological processes. While this isn't proof of life, it suggests that something unusual is happening in Venus's clouds, where temperatures and pressures are much milder than on the planet's surface. The discovery reignited interest in exploring Venus further, possibly with probes designed to study its atmosphere more closely. Beyond our own solar system, the possibility of life existing on exoplanets continues to captivate astronomers. The James Webb Space Telescope, launched in 2021, is a game-changer in this quest. With its ability to analyze the atmospheres of distant planets, Webb can detect the chemical fingerprints of gases like oxygen, methane, and carbon dioxide, gases that could hint at the presence of life. By studying these planets, we can begin to understand what makes a world habitable and how common life might be in the universe. One of the most intriguing possibilities for extraterrestrial life comes not from planets, but from moons. Jupiter's moon Europa and Saturn's moon Enceladus are prime candidates for hosting life due to the presence of subsurface oceans beneath their icy crusts. NASA's upcoming Europa Clipper mission, set to launch in the 2020s, will investigate the potential for life in Europa's ocean. Scientists believe that hydrothermal vents on the ocean floor, similar to those found on Earth, could provide the necessary energy to support microbial life. Meanwhile, Enceladus has already given us a tantalizing clue. Plumes of water vapor containing organic molecules have been observed shooting out from its surface, suggesting that its subsurface ocean could be rich in the building blocks of life. The search for life isn't just about biology, it's also about finding out more about the conditions that make life possible. For instance, water is essential for life as we know it, but space exploration has shown that water is far more abundant in the universe than previously thought. Water has been found not only on Mars but also on the Moon, in the form of ice at its poles, and even in the distant reaches of interstellar space, where icy comets and asteroids harbor frozen water. This discovery has important implications for the future of space exploration. If we can locate and extract water on other worlds, it could be used to support human life, providing drinking water, oxygen, and even fuel through the process of electrolysis. The possibility of human life expanding beyond Earth is no longer the stuff of science fiction. NASA, along with private companies like SpaceX, has ambitious plans to send humans to Mars within the next decade. Establishing a human presence on Mars would be a monumental achievement, but it also poses enormous challenges. The planet's thin atmosphere, which is mostly carbon dioxide, offers little protection from harmful cosmic radiation, and temperatures can drop to as low as -100 degrees Celsius at night. But Mars has resources that could be harnessed to support human life, including water ice, which could be converted into breathable air and rocket fuel. Technologies like 3D printing could be used to construct habitats from Martian soil, reducing the need to transport building materials from Earth. While Mars is often seen as the most likely candidate for human colonization, other destinations are also being considered. The Moon, which is much closer to Earth, could serve as a stepping stone for deeper space exploration. NASA's Artemis program aims to return humans to the lunar surface by the mid-2020s, with the goal of establishing a sustainable presence on the Moon by the end of the decade. The lunar South Pole, where water ice has been detected, is a prime location for a future moon base. Such a base could serve as a launching pad for missions to Mars and beyond, as well as a site for scientific research and commercial activities like mining for rare elements. But while we look to the future of space exploration, we must also contend with the potential dangers that space presents. One of the most immediate threats comes from asteroids. The Earth has been struck by asteroids before, most famously 66 million years ago, when a massive impact wiped out the dinosaurs. Today, efforts are underway to track and potentially deflect near-Earth objects that could pose a threat to our planet. In 2022, NASA's DART mission successfully demonstrated the ability to alter the trajectory of an asteroid by crashing a spacecraft into it. This type of planetary defense system could one day save Earth from a catastrophic impact. Another danger that looms on the horizon is space junk. As humanity sends more and more satellites into orbit, the problem of space debris becomes more pressing. There are currently thousands of pieces of defunct satellites, spent rocket stages, and other debris circling Earth at high speeds. Even a small piece of debris can cause significant damage to spacecraft or satellites if they collide. In response, organizations around the world are developing strategies to mitigate this risk, including ideas for removing debris from orbit or designing satellites that can deorbit themselves when they are no longer in use. Despite these challenges, space exploration is entering a new golden age. Private companies are playing a larger role than ever before, driving down the cost of launching satellites and sending missions to space. SpaceX's reusable rockets have revolutionized the industry, making space more accessible and opening up the possibility of commercial space travel. In the near future, space tourism could become a reality, with companies like Blue Origin and Virgin Galactic offering brief trips to the edge of space. While these flights are currently available only to the ultra-wealthy, advancements in technology could eventually make space travel affordable for a wider audience. One of the most inspiring aspects of space exploration is how it unites humanity. In space, there are no borders, no divisions between countries. The International Space Station, ISS, is a shining example of international cooperation, with astronauts from different nations living and working together in orbit for over 2 decades. The ISS serves as a laboratory for experiments in everything from biology to materials science, helping us to understand how life adapts to the conditions of space. As plans for a new space station, the Lunar Gateway, take shape, the tradition of collaboration in space exploration continues. Looking ahead, the next great leap may be the development of space habitats, self-sustaining colonies that could exist in orbit around Earth or on other planets. These habitats would need to provide everything humans require to survive, from air and water to food and protection from cosmic radiation. Engineers are already designing concepts for space habitats that use centrifugal force to simulate gravity and closed-loop systems to recycle air and water. While we are still far from achieving these goals, the technology needed to build a sustainable human presence in space is advancing rapidly. The exploration of space has always pushed the boundaries of human knowledge and imagination. From the first steps on the moon to the ongoing search for life on other worlds, each discovery reminds us of how much there is left to learn. As we venture further into the cosmos, we are not just searching for answers to our most profound questions about existence, but also unlocking the potential for humanity to thrive beyond the confines of Earth. Whether we are alone in the universe or part of a vast cosmic community, the journey into space promises to redefine our place in the cosmos and reveal wonders we have yet to imagine. As our journey into space continues, the question of how humans might adapt to long-term space travel becomes ever more pressing. Space is a hostile environment for life as we know it. Beyond Earth's protective atmosphere, astronauts are exposed to a variety of dangers, from cosmic radiation to the effects of weightlessness on the human body. Prolonged exposure to microgravity, for example, can cause muscle atrophy, bone density loss, and changes in vision. To counter these effects, astronauts aboard the International Space Station, ISS, follow rigorous exercise routines, but long-term missions, such as a trip to Mars, will require even more advanced solutions. One of the most promising areas of research is artificial gravity. Scientists are exploring the possibility of creating rotating spacecraft that use centrifugal force to simulate gravity. This would allow astronauts to maintain their muscle strength and bone density over extended periods in space. While the technology to build such habitats is still in its early stages, experiments aboard the ISS and other research stations are helping to advance our understanding of how artificial gravity could work. If successful, this technology could be a game-changer for future space colonies, allowing humans to live and work in space without suffering the debilitating effects of microgravity. Another challenge facing long-term space exploration is radiation. In space, astronauts are exposed to much higher levels of radiation than on Earth, particularly from cosmic rays and solar flares. This radiation can damage DNA and increase the risk of cancer and other health problems. On Earth, our atmosphere and magnetic field provide a natural shield against most of this radiation. But in space, more robust protection is needed. Researchers are developing a variety of shielding technologies to protect astronauts, including advanced materials that can absorb or deflect radiation. One idea is to use water, which is an excellent radiation shield, as part of the spacecraft's design, placing water tanks around the crew quarters to provide additional protection. But it's not just the physical challenges of space that we need to consider. The psychological effects of isolation and confinement during long missions are equally important. Studies of astronauts on the ISS, as well as simulations of Mars missions here on Earth, have shown that living in a confined space for months or years at a time can lead to stress, depression, and interpersonal conflicts. To address these issues, space agencies are studying ways to improve mental health in space, including better communication with Earth, virtual reality environments to simulate outdoor spaces, and even the possibility of sending crews with companion animals to boost morale. One of the key factors in ensuring the success of long-duration space missions will be the development of self-sustaining life support systems. On Earth, we take for granted the availability of air, water, and food, but in space, every resource must be carefully managed. The ISS currently relies on resupply missions from Earth to bring food, water, and other necessities, but on a mission to Mars, this won't be possible. Instead, future spacecraft will need to recycle water and air and produce food in space. NASA and other space agencies are already testing closed-loop life support systems that recycle waste products and convert them back into usable resources. For example, water recovery systems aboard the ISS can purify urine and sweat, turning them back into drinking water, a vital technology for long-duration missions. Growing food in space is another crucial challenge. Plants not only provide a source of food, but also help recycle carbon dioxide into oxygen, making them an essential part of any closed-loop life support system. Experiments aboard the ISS have already demonstrated that it is possible to grow plants in microgravity, but researchers are still working to optimize these systems for long-term use. Space farming might involve hydroponic systems, which grow plants without soil, or even genetically engineered plants designed to thrive in the unique conditions of space. In the future, astronauts could rely on space-grown crops to provide fresh food on missions to Mars or beyond, reducing the need for resupply missions from Earth. The concept of space colonization, creating permanent human settlements on other planets or moons, is one of the most exciting possibilities of space exploration. Mars is often seen as the most likely candidate for colonization due to its relatively similar day length, the presence of water ice, and its potential to be terraformed. Terraforming Mars would involve altering the planet's atmosphere and climate to make it more Earth-like, perhaps by releasing greenhouse gases to warm the planet and create a thicker atmosphere. While this idea is still far in the future, it represents one of the boldest visions for humanity's future in space. Building colonies on the Moon is another option that could happen sooner. The Moon is much closer to Earth, making it a more accessible target for early colonization efforts. The Artemis program, led by NASA, plans to return humans to the Moon and establish a sustainable presence by the 2030s. A lunar base could serve as a proving ground for technologies that will be needed for Mars missions, such as in-situ resource utilization, using local materials to build structures and produce oxygen and fuel. The Moon's surface is rich in regolith, a fine, powdery dust that could be used as building material for habitats or even processed to extract valuable resources like oxygen. One of the most tantalizing possibilities of space colonization is the idea of mining asteroids. Asteroids are rich in metals and minerals, including rare elements that are in short supply on Earth, such as platinum, gold, and iridium. In the future, asteroid mining could become a major industry, providing the raw materials needed to build and sustain colonies in space. Several private companies, such as Planetary Resources and Deep Space Industries, are already exploring the potential of asteroid mining. And while the technology is still in its infancy, it could one day revolutionize space exploration by making space-based industries self-sufficient. But the drive to explore space is not just about survival or profit. It's also about discovery. The human thirst for knowledge is insatiable, and space offers a virtually limitless frontier for exploration. As we develop the technology to travel farther and faster, we may one day reach the outer planets of our solar system, or even venture beyond to explore neighboring star systems. Projects like Breakthrough Starshot are already looking into the possibility of sending tiny, high-speed probes to Alpha Centauri, the closest star system to Earth. While the journey would take decades, it would be our first step toward exploring the stars. The discovery of alien life, whether microbial or intelligent, would be one of the most profound moments in human history. If life exists elsewhere in the universe, it could take many forms, some of which might be completely different from anything we know on Earth. Scientists are already searching for signs of extraterrestrial life by listening for radio signals from distant civilizations and studying the atmospheres of exoplanets for signs of life. While we have yet to find definitive evidence of life beyond Earth, the search continues, fueled by the belief that, in a universe as vast as ours, we cannot be alone. As we look toward the future, one thing is clear: space is the next great frontier for humanity. Whether we are driven by the search for new resources, the desire to expand our civilization, or the simple curiosity to explore the unknown, space holds endless possibilities. Each new discovery, each step forward, brings us closer to a future where humans are not just confined to Earth, but are a truly spacefaring species, exploring, living, and thriving among the stars. As humanity continues to push the boundaries of space exploration, we are increasingly confronted with the profound question of how far we can truly go. The scale of the universe is mind-boggling, and even with the most advanced technologies, traveling to the far reaches of our galaxy or beyond remains a monumental challenge. But what if there were ways to leap beyond our current limitations? Concepts like warp drives, wormholes, and other theoretical forms of faster-than-light travel have captured the imagination of scientists and science fiction enthusiasts alike. While these ideas are still speculative, they open the door to incredible possibilities about how we might one day explore the cosmos. The idea of a warp drive, inspired by the world of science fiction, particularly Star Trek, is based on the concept of bending or warping space-time itself. Instead of moving faster than the speed of light, which, according to Einstein's theory of relativity, is impossible for any object with mass, a warp drive would theoretically compress space in front of a spacecraft and expand it behind, effectively allowing the ship to ride a wave of distorted space-time. In 1994, theoretical physicist Miguel Alcubierre proposed a mathematical model for such a drive, known as the Alcubierre drive, which suggests that faster-than-light travel could be achieved without violating the laws of physics. However, the energy required for such a drive would be astronomical, far beyond anything we can currently generate. Some estimates suggest it would require the energy equivalent to the mass of an entire planet, if not more, to power a warp bubble. Despite these challenges, research continues, and advancements in quantum physics and our understanding of space-time could one day make the impossible a reality. Another tantalizing possibility for deep space travel is the use of wormholes. Wormholes, or Einstein-Rosen bridges, are theoretical passages through space-time that could connect two distant points in the universe, effectively creating a shortcut. If such structures exist, they could allow for near-instantaneous travel across vast cosmic distances. The idea comes from the equations of general relativity, which suggest that under the right conditions, space-time can fold in on itself, creating a tunnel-like structure. The challenge with wormholes, however, is that they would be incredibly unstable. Any matter entering a wormhole would cause it to collapse, unless some form of exotic matter, with negative energy, could be used to stabilize it. While no direct evidence for wormholes has been found, scientists continue to explore the mathematical possibilities, keeping the dream of interstellar travel alive. While warp drives and wormholes remain in the realm of theoretical physics, there are other more immediate strategies being developed for deep space exploration. One of the most promising is solar sail technology, which uses sunlight to propel a spacecraft. Solar sails work by reflecting photons from the sun off a large, mirror-like surface, using the momentum of the light particles to generate thrust. Though the force from individual photons is tiny, over time, and in the vacuum of space, a solar sail could gradually accelerate a spacecraft to extremely high speeds without the need for fuel. The Breakthrough Starshot initiative, funded by Silicon Valley billionaire Yuri Milner, aims to use this technology to send tiny, lightweight probes to the Alpha Centauri system at 20% of the speed of light. These probes, equipped with cameras and scientific instruments, could reach our nearest stellar neighbor in just over 20 years, offering humanity its first close-up look at another star system. Another innovative approach to space travel is nuclear propulsion. Traditional chemical rockets are limited by the amount of energy they can produce, but nuclear-powered rockets could provide a much more efficient and powerful means of propulsion. NASA and private companies are currently researching nuclear thermal propulsion, NTP, and nuclear electric propulsion, NEP systems, which could drastically reduce the travel time to Mars and other distant destinations. NTP uses a nuclear reactor to heat a propellant, such as hydrogen, to produce thrust, while NEP generates electricity from a nuclear reactor to power electric thrusters. These technologies, if fully developed, could revolutionize space exploration, allowing us to reach the outer planets of our solar system much more quickly and with far less fuel than current methods. One of the most futuristic concepts being explored is the idea of antimatter propulsion. Antimatter is the mirror opposite of regular matter, consisting of particles like positrons, the antimatter counterpart of electrons, and antiprotons. When matter and antimatter collide, they annihilate each other in a burst of energy, releasing far more power than any chemical or nuclear reaction. If we could harness this energy, antimatter propulsion could propel spacecraft at incredible speeds, potentially allowing for interstellar travel within human lifetimes. However, antimatter is extremely rare and difficult to produce. Currently, only minute amounts of antimatter can be generated in particle accelerators, and storing it safely is another major challenge, as it annihilates upon contact with regular matter. Still, the potential of antimatter is so great that it remains an area of active research, with the hope that one day we might unlock its full potential for space travel. While faster-than-light travel remains speculative for now, humanity has already made significant progress in exploring our own solar system and beyond. Space probes like Voyager 1 and 2, launched in 1977, have traveled farther than any other human-made objects, now venturing into interstellar space after completing their missions to explore the outer planets. These spacecraft continue to send back valuable data, even as they drift further from Earth. The success of missions like these demonstrates that, while interstellar travel may still be out of reach, we are capable of exploring the vastness of space with the technology we have today. One area of space exploration that has seen rapid advancement is the study of astrobiology, the search for life beyond Earth. As our understanding of exoplanets grows, so too does our ability to pinpoint potential habitats for life. With missions like NASA's James Webb Space Telescope and the European Space Agency's upcoming aerial mission, we are getting closer to analyzing the atmospheres of distant planets for signs of life. These missions can detect biomarkers, gases like oxygen, methane, and ozone, that could indicate the presence of biological processes. If we were to discover even the faintest hint of life on another planet, it would fundamentally change our understanding of the universe and our place within it. As we expand our search for life, we are also learning more about the potential habitability of moons and dwarf planets within our own solar system. Europa, one of Jupiter's moons, and Enceladus, a moon of Saturn, both have subsurface oceans beneath their icy crusts. These oceans are kept warm by the gravitational forces exerted by their parent planets, creating conditions that could support life. Recent missions have detected plumes of water vapor erupting from the surface of Enceladus, and future missions aim to sample these plumes for signs of microbial life. Similarly, the upcoming Europa Clipper mission will investigate Europa's ice shell and ocean, searching for clues about the moon's potential to harbor life. Beyond moons and planets, even some of the smallest objects in our solar system may hold surprises. Comets, which are composed of ice, dust, and organic molecules, are often seen as relics of the early solar system. Some scientists believe that comets may have played a key role in delivering water and organic compounds to Earth, potentially kickstarting life on our planet. By studying comets and asteroids up close, as missions like Rosetta and OSIRIS-Rx have done, we can learn more about the origins of our solar system and the building blocks of life. While the exploration of space continues to reveal new wonders, it also poses ethical and philosophical questions. As we reach further into the cosmos, we must consider the impact of human activity on other worlds. The possibility of contaminating extraterrestrial environments with Earth microbes is a serious concern, as it could interfere with the search for native life forms. For this reason, space agencies follow strict planetary protection protocols, ensuring that spacecraft are thoroughly sterilized before landing on other planets or moons. At the same time, the potential discovery of life elsewhere raises profound questions about our role as stewards of the universe. How would we treat alien life forms? Should we encounter them? Would we see ourselves as explorers or as invaders? Ultimately, space exploration is not just about the technology or the destinations. It's about pushing the boundaries of human knowledge and imagination. Each new discovery, whether it's a distant exoplanet or a microscopic organism hidden beneath an icy moon, brings us closer to answering the age-old questions. Where do we come from? Are we alone? And what is our future in this vast, mysterious universe? As we stand on the brink of a new era in space exploration, it's clear that the journey ahead will be filled with challenges, triumphs, and perhaps even surprises beyond our wildest dreams. Whether we are exploring the surface of Mars, probing the depths of Europa's oceans, or one day venturing to the stars, the possibilities are as limitless as the universe itself. And as we continue to reach for the stars, we carry with us the hopes and dreams of all those who have looked up at the night sky and wondered what lies beyond. As our exploration of space continues to advance, the potential for human expansion beyond Earth brings about some of the most profound and transformative possibilities for our civilization. The idea that one day humans might live and thrive on other planets, moons, or even artificial habitats in space leads us to think deeply about the next great step for humanity, becoming a multiplanetary species. This vision is not just about survival, although ensuring humanity's long-term existence in the face of threats like asteroid impacts, climate change, or other existential risks is certainly a strong motivation. It's also about the growth of human knowledge, the pursuit of discovery, and the drive to explore new frontiers. Mars stands at the forefront of this vision, not just because of its proximity to Earth, but because it offers a landscape that, while harsh and unforgiving, still holds the most potential for human settlement among the planets in our solar system. The idea of colonizing Mars, once the stuff of pure science fiction, is now being seriously pursued by space agencies and private companies alike. NASA's Artemis program, aimed at returning humans to the moon, is seen as a stepping stone for eventually sending astronauts to Mars. Meanwhile, Elon Musk's SpaceX has laid out an ambitious plan to send humans to Mars within the next decade, with the long-term goal of establishing a self-sustaining colony. But settling Mars is no small task. The challenges are immense, starting with the sheer difficulty of getting there. The journey to Mars takes around 6 to 9 months, depending on the alignment of the planets. And once there, astronauts will face a planet with a thin atmosphere, frigid temperatures, and high levels of radiation. The lack of a breathable atmosphere means that any human presence on Mars will require advanced life support systems, habitats with artificial atmospheres, and ways to grow food in an environment where liquid water does not exist on the surface. One of the first priorities for a Martian colony would be harnessing the resources of the planet to reduce reliance on supplies from Earth. This concept, known as in situ resource utilization, ISRU, would involve using Martian materials to produce water, oxygen, and even fuel. Mars has significant amounts of frozen water, particularly at its poles and potentially beneath the surface in other regions. Technologies like ice mining and electrolysis could extract this water and split it into hydrogen and oxygen, providing both drinking water and breathable air. The oxygen could also be used in rocket fuel, making it possible to launch missions from Mars back to Earth or other destinations. The production of food on Mars is another critical challenge. While scientists have already begun experimenting with growing plants in simulated Martian soil here on Earth, the thin atmosphere and lack of liquid water mean that Martian farming will likely need to take place in controlled environments, such as greenhouses or underground farms. These systems would need to recycle air, water, and nutrients to create a closed-loop system, much like the life support systems aboard the International Space Station. Advances in hydroponics and aquaponics, systems that allow plants to grow without soil, could play a key role in creating sustainable food sources on Mars. Building habitats on Mars will also require innovation. Traditional space habitats, designed for short-term missions, will not suffice for long-term living on a hostile planet. The Martian atmosphere provides little protection from cosmic radiation and solar storms, so habitats would need to be built underground or shielded with thick layers of regolith, the Martian soil, to protect their inhabitants. One promising idea is to use 3D printing technology to construct these habitats using materials found on Mars. NASA has already run competitions to design Martian habitats that can be built using local resources, and the technology to create sturdy, livable structures is advancing rapidly. While Mars represents the most feasible target for human colonization in the near term, other possibilities also beckon. The Moon, much closer to Earth, offers a testing ground for many of the technologies and strategies that will be used on Mars. With plans to establish a permanent lunar base as part of the Artemis program, the Moon could serve as a launch point for missions deeper into space. The Moon's low gravity makes it an ideal location for constructing spacecraft or fuel depots, and its surface contains valuable resources, including water ice in its polar regions, that could support human life and industrial activities. Beyond the Moon and Mars, the moons of the outer planets hold fascinating possibilities for future exploration and even colonization. Europa, Ganymede, and Callisto, moons of Jupiter, and Enceladus and Titan, moons of Saturn, all have subsurface oceans or atmospheres that could potentially support life or provide resources for human explorers. Titan, with its thick atmosphere and lakes of liquid methane and ethane, presents a particularly intriguing case. While its frigid temperatures and alien chemistry make it a challenging environment, some scientists speculate that Titan's resources could one day be harnessed to support a human presence or robotic operations. As we think about the long-term future of space colonization, the idea of space habitats, massive self-sustaining structures built in orbit, also gains traction. These habitats, often referred to as space stations on a much larger scale, could house thousands of people and provide Earth-like environments through the use of centrifugal force to create artificial gravity. Concepts like the O'Neill cylinder, a rotating space habitat first proposed by physicist Gerard O'Neill in the 1970s, offer a vision of space cities that could float between planets or orbit Earth, providing homes for humans as we expand beyond our home planet. While such structures remain in the conceptual stage, advances in materials science and space engineering could one day make these habitats a reality. However, with the potential for expanding humanity's reach into space comes significant ethical and philosophical considerations. As we set our sights on other worlds, we must grapple with questions about our responsibilities as explorers. For example, if we discover microbial life on Mars or another planet, what obligation do we have to protect that life? Should we prioritize human colonization, or should the preservation of alien ecosystems take precedence? These questions highlight the need for careful consideration of planetary protection policies as we venture into the unknown. Moreover, as space exploration becomes more commercialized, the question of who controls space resources becomes increasingly important. International space treaties, such as the Outer Space Treaty of 1967, state that space is the province of all mankind and prohibit any nation from claiming sovereignty over celestial bodies. But as private companies develop plans to mine asteroids, extract resources from the Moon, and build infrastructure in space, the legal and regulatory frameworks governing these activities will need to evolve. Ensuring that space remains a domain for peaceful exploration and scientific discovery, rather than a site for conflict or exploitation, will be one of the key challenges of the coming decades. The future of space exploration and colonization also raises questions about the social and cultural impact of becoming a multiplanetary species. How will societies be structured on other worlds? What kind of governance will emerge in space colonies? Will humans born on Mars or in space habitats see themselves as fundamentally different from those who remain on Earth? As we extend human civilization beyond Earth, we may encounter new forms of identity, community, and culture that reflect the unique environments and challenges of living in space. There's also the possibility that, as we explore the universe, we may one day encounter intelligent extraterrestrial civilizations. The famous Drake equation, developed by astronomer Frank Drake in the 1960s, attempts to estimate the number of advanced civilizations in our galaxy. While we have yet to detect any signs of intelligent life, the discovery of even the simplest life forms on another planet would revolutionize our understanding of biology, evolution, and the place of humanity in the universe. The search for extraterrestrial intelligence, SETI, continues, with scientists scanning the skies for signals that might indicate the presence of other civilizations. Whether we are alone in the cosmos or one of many civilizations scattered throughout the stars remains one of the greatest unanswered questions. In the meantime, humanity's journey into space is just beginning. From the earliest stargazers to the astronauts orbiting Earth today, our curiosity about the cosmos has driven us to explore, innovate, and dream. The challenges of space exploration are daunting, but they are not insurmountable. With each technological breakthrough, each new discovery, we move closer to a future where humans are not confined to a single planet, but are instead part of a vast and interconnected cosmic community. As we prepare for this future, it's important to remember that space exploration is not just about science or technology. It's about the human spirit. It's about pushing the boundaries of what we thought was possible, seeking out the unknown, and daring to dream of a future that is bigger than ourselves. Whether we are building habitats on Mars, exploring the moons of Jupiter, or constructing cities in space, the next century promises to be a time of extraordinary exploration and discovery. And as we continue this journey, we take with us the hope and belief that the stars are not beyond our reach, but are simply the next destination on humanity's endless quest for knowledge and adventure. As we venture even further into the depths of space, the prospect of humanity becoming a truly interstellar species begins to move from science fiction to a theoretical reality. The technological and societal shifts necessary to achieve such a leap are vast, but the potential rewards are equally immense. One of the primary drivers behind this vision is the search for new homes among the stars, other planetary systems where humans could potentially thrive. This requires not only the ability to reach distant star systems, but also the discovery of planets that can support life. Fortunately, the search for exoplanets has already yielded some fascinating results. With many planets discovered in the so-called habitable zone, the region around a star where conditions may be right for liquid water, and by extension, life, to exist. One of the most promising exoplanets discovered is Proxima b, orbiting the star Proxima Centauri, which is the closest star to our solar system at a distance of just over 4 light-years. While Proxima b is located in its star's habitable zone, where temperatures might allow for the presence of liquid water, the planet's environment is likely to be far from Earth-like. Proxima Centauri is a red dwarf, a type of star known for emitting intense stellar flares that could strip away the atmosphere of a nearby planet, exposing its surface to harmful radiation. Despite these challenges, the discovery of Proxima b has fueled interest in the idea of sending probes, or even humans, to explore other star systems. The technological leap required to travel to another star system is immense. Even the fastest spacecraft we have today would take tens of thousands of years to reach Proxima Centauri. To realistically consider interstellar travel, we need to develop propulsion systems that can reach a significant fraction of the speed of light. One proposed method is the use of laser-driven light sails, a technology that is being actively explored by projects like Breakthrough Starshot. In this concept, powerful lasers based on Earth or in space would propel lightweight probes equipped with reflective sails, allowing them to accelerate to speeds of up to 20% of the speed of light. This would enable a probe to reach Proxima Centauri in just over 20 years, making it the first human-made object to travel beyond our solar system. While such probes could send back valuable data, the dream of sending humans to other stars remains a much larger challenge. For humans to undertake such a journey, we would need spacecraft capable of supporting life for extended periods, potentially for generations, as well as propulsion systems far more advanced than anything we currently possess. Some theorists have proposed the idea of generation ships, enormous spacecraft designed to carry entire populations who would live, work, and raise families on board over the course of centuries-long journeys. Such a vessel would be a self-contained world, with closed-loop life support systems, artificial ecosystems, and everything needed to sustain human life across multiple generations. However, The concept of a generation ship raises significant ethical and philosophical questions. What would life be like for the generations born on such a ship, knowing that they would never set foot on the destination planet, but were simply part of a centuries-long journey to ensure the survival of future generations? How would these communities maintain social cohesion, a sense of purpose, and technological progress over such long periods of time? And what if, during the course of the journey, humanity developed new technologies that could reach the destination in a fraction of the time, effectively rendering the generation ship obsolete? An alternative to the generation ship model is the concept of cryogenic sleep or suspended animation. This idea, long a staple of science fiction, involves placing astronauts into a state of deep sleep or stasis for the duration of the journey, allowing them to wake up upon arrival at their destination. While we are still far from developing the technology to safely place humans into long-term stasis, researchers are exploring the possibility of using cryopreservation or metabolic suppression to extend the viability of cells and tissues. In theory, if we could slow down or halt the aging process, humans could survive long interstellar journeys without the need for massive multi-generational ships. Another speculative, yet intriguing idea is the possibility of uploading human consciousness into machines or digital systems, allowing our minds to travel the vast distances between stars without the limitations of a biological body. This concept, known as mind uploading or whole brain emulation, suggests that one day we might be able to scan and replicate the human brain's neural structure and upload it into a digital environment. While this idea faces significant scientific and ethical challenges, it opens up the possibility of sending virtual versions of ourselves to explore distant worlds, or even live indefinitely in artificial environments. Interstellar travel also brings us back to the fundamental question of whether we are alone in the universe. The discovery of even microbial life on another planet would have profound implications for our understanding of biology, evolution, and our place in the cosmos. But the discovery of intelligent life would be an even more transformative event. The search for extraterrestrial intelligence, SETI, has been ongoing for decades, primarily through the use of radio telescopes scanning the sky for signals that could be evidence of advanced civilizations. So far, no definitive signals have been detected, but the search continues, with ever more sophisticated technologies and techniques. Some scientists have proposed that advanced civilizations, if they exist, might be using forms of communication beyond our current understanding. For example, they might use quantum communication, or even signals based on principles of physics that we have not yet discovered. Another possibility is that advanced civilizations could be operating on scales or in dimensions that we cannot currently perceive, making them invisible to our current methods of detection. If intelligent life exists elsewhere in the universe, the vast distances between stars could make communication incredibly difficult. A signal sent from a civilization in a distant galaxy, for example, could take millions of years to reach us, meaning that by the time we receive it, that civilization could already be extinct. This idea, known as the cosmic haystack problem, illustrates the enormity of the challenge in finding extraterrestrial civilizations. We are searching for a needle in a haystack that spans not just the vastness of space, but also the depth of time. Some theorists have even proposed that the absence of detectable signals could be explained by the Great Filter hypothesis, which suggests that there is some stage in the development of intelligent civilizations that is extremely difficult to pass, perhaps involving self-destruction or environmental collapse. If this is true, it might explain why we have not yet encountered any evidence of other advanced civilizations. Despite the challenges, the search for life and the dream of interstellar exploration continue to inspire scientists and visionaries alike. The discovery of alien life, whether intelligent or microbial, would be one of the most significant events in human history, forcing us to rethink our understanding of the universe and our place within it. Moreover, the prospect of expanding human civilization beyond Earth, of establishing colonies on other planets, or traveling to other star systems, represents the next great chapter in the story of human exploration. As we look to the future, it's clear that the road to becoming an interstellar species will be long and filled with challenges, but the potential rewards are immeasurable. From the creation of sustainable colonies on Mars to the development of faster-than-light propulsion, Each step forward brings us closer to a future where humanity is no longer confined to a single planet, but is spread across the stars. Along the way, we will undoubtedly face setbacks, but the desire to explore, to discover, and to push the boundaries of what is possible is deeply ingrained in our species. The universe, with all its mysteries and wonders, is out there waiting to be explored. Whether we are driven by the search for new knowledge, the desire to ensure the survival of our species, or the simple human instinct to explore, the journey into the cosmos promises to reshape our future in ways we can scarcely imagine. And perhaps, one day, we will find ourselves not just looking up at the stars from a distant planet, but traveling between them, part of a galactic civilization that spans the cosmos. As humanity takes its first tentative steps toward becoming an interstellar species, we are also forced to confront some of the deeper philosophical and existential questions that arise from exploring the vast cosmos. What does it mean to be human in an environment so alien and unforgiving? How will the experiences of living in space or on other planets shape our understanding of ourselves, our cultures, and our relationship to Earth? Space exploration is not just about technological advancement or scientific discovery. It is also a journey that will challenge and redefine the very essence of what it means to exist. One of the most significant changes we will likely face as we expand into space is the concept of identity. For millennia, humans have defined themselves by their connection to the land, their culture, and the communities around them. But in space, these connections will inevitably shift. Life in a space colony or on another planet will be unlike anything humans have ever experienced. The physical environment will be dramatically different, with lower gravity, artificial atmospheres, and entirely new ecosystems, if they exist at all. Over time, these changes could lead to the emergence of new identities and cultures, shaped by the unique challenges and opportunities of life beyond Earth. For example, humans born and raised on Mars might come to see themselves as distinctly Martian, with their own customs, values, and ways of life that differ significantly from those on Earth. The harsh conditions of Mars, where survival depends on collective effort and careful management of resources, could foster a strong sense of community and interdependence. On the other hand, the physical and psychological isolation of living on a distant planet could also lead to new forms of individualism or even a shift in how we perceive time and space. A Martian day, or sol, is longer than an Earth day, and the planet's year is nearly twice as long. These differences could lead to entirely new ways of organizing daily life, work, and leisure. Moreover, the physical environment of space and other planets could lead to changes in human biology over time. Prolonged exposure to lower gravity, for instance, might lead to changes in muscle and bone structure, making future generations of spaceborne humans physically different from those who remain on Earth. There is even speculation that, over the course of many generations, humans living on Mars or in space habitats could evolve into entirely new subspecies, adapted to their environments in ways that we cannot yet fully predict. Such evolutionary changes, if they occur, would raise profound questions about the nature of human diversity and the concept of a shared human identity. This brings us to the ethical dimensions of space colonization. As we move into new environments, how will we ensure that the mistakes of Earth are not repeated? The environmental degradation and exploitation of natural resources that have characterized much of human history could take on even more devastating forms in space, where ecosystems are fragile or non-existent, and the stakes for survival are incredibly high. For example, the extraction of resources from asteroids or planets might provide the materials needed to support life in space, but it could also lead to the destruction of potential habitats or the contamination of environments that might harbor life. To avoid such outcomes, space agencies and private companies will need to adopt rigorous environmental protections and ethical guidelines for space exploration and colonization. These might include principles of planetary protection, ensuring that we do not contaminate other worlds with Earth-based life, and that we take care to preserve any native ecosystems we might encounter. There is also the question of how to equitably distribute the benefits of space exploration. As private companies increasingly enter the space race, the potential for space resources to become a source of wealth and power raises concerns about inequality and the monopolization of space. The ethical challenges of space colonization extend beyond environmental concerns. The psychological well-being of humans living in space will be another critical issue. Space is a fundamentally isolating environment, where the distances between people, both physically and emotionally, are magnified. The mental health effects of long-term space travel, isolation, and confinement have been well documented in astronauts who spend extended periods aboard the International Space Station. These effects are likely to be even more pronounced for those living in space colonies or on distant planets, where the connection to Earth is distant and the sense of isolation is much more profound. To address these challenges, future space colonies will need to place a strong emphasis on psychological support, community building, and mental health care. Technologies such as virtual reality could help alleviate some of the psychological strain by allowing colonists to experience Earth-like environments or connect with loved ones back home. However, no technology can fully replace the sense of belonging and connection that comes from living within a familiar environment and culture. Over time, space colonies will need to develop their own social structures, traditions, and support systems to maintain the mental and emotional well-being of their inhabitants. At the same time, space exploration offers the potential for entirely new forms of human experience and creativity. Living in space or on other planets will require us to rethink how we approach art, culture, and self-expression. The unique environments of space could inspire new forms of architecture, music, and visual art that reflect the alien landscapes and experiences of life beyond Earth. Imagine, for instance, a new form of sculpture that takes advantage of the low gravity of the Moon or Mars, or music composed to reflect the rhythms of life in a space colony, where the passage of time and the cycles of day and night are entirely different from those on Earth. Space also offers the potential for entirely new forms of spirituality and philosophical reflection. The experience of looking down at Earth from space, known as the overview effect, has been described by many astronauts as a profoundly spiritual and transformative experience. From space, the boundaries between nations disappear, and the fragility of our planet becomes strikingly clear. As we venture further into the cosmos, we may encounter new questions about our place in the universe and our relationship to the unknown. The vastness of space, the possibility of encountering alien life, and the challenges of survival in such a hostile environment could lead to new forms of spiritual and philosophical thought, as humans seek to make sense of their experiences and the larger context of their existence. In the distant future, space exploration might also change the way we think about life and consciousness itself. As we develop more advanced technologies such as artificial intelligence and robotics, the lines between human and machine might blur. Space exploration could accelerate these trends, as robots and AI systems play an increasingly important role in helping humans explore and colonize the cosmos. In time, we might even see the emergence of hybrid beings, part human, part machine, designed to survive and thrive in the harsh environments of space. These beings might challenge our very notions of what it means to be alive or conscious, raising new ethical and philosophical questions about the nature of life and intelligence. In many ways, space is the ultimate frontier for human imagination. It is a place where the limits of our knowledge, technology, and creativity are constantly being pushed and redefined. As we continue to explore and expand into the cosmos, we will undoubtedly encounter challenges and dilemmas that we cannot yet fully anticipate. But space exploration also offers the potential for extraordinary discoveries about the universe, about life, and about ourselves. The journey into space is not just a technological endeavor, it is a profoundly human one. It will require us to confront our deepest fears and hopes, to rethink the way we live and interact with our environment, and to continuously question what it means to be human in a universe that is far larger and more mysterious than we can ever fully comprehend. As we look to the stars, we are not just seeking new worlds to explore, we are also seeking new ways to understand ourselves and our place in the cosmos. And as we take our first steps into this new frontier, we carry with us the spirit of exploration and the belief that, no matter how far we go, the journey itself will be as transformative as any destination we might reach. As humanity pushes ever deeper into space, We are on the cusp of transforming not only our understanding of the cosmos, but also the way we think about our future as a species. The challenges and opportunities of this new era of exploration will shape the evolution of human society, technology, and even our biology. Each new discovery and innovation will prompt us to reconsider fundamental aspects of our existence, our relationships to each other, to the Earth, and to the universe itself. As we contemplate the long-term implications of space exploration, we must also reckon with the potential for profound changes in the ways we organize our societies, economies, and governance structures. One of the most striking possibilities raised by space colonization is the formation of new political systems and governance models. The vast distances between planets, moons, and space colonies will create entirely new geopolitical dynamics. Unlike on Earth, where nations are divided by borders, in space, the isolation and remoteness of different settlements will force us to rethink how societies are organized and governed. Space colonies, whether on Mars, the Moon, or in orbital habitats, will likely develop their own unique systems of governance that reflect the specific challenges and environments in which they are situated. For example, the necessity of cooperation and resource sharing in a hostile space environment might lead to more collective or cooperative forms of governance. In a Martian colony, where survival depends on careful management of air, water, and food, decisions about resource allocation could be made by councils or assemblies of colonists rather than by distant authorities on Earth. Similarly, space habitats that rely on closed-loop ecosystems and life support systems might develop governance structures that emphasize sustainability, long-term planning, and consensus building to ensure the well-being of future generations. At the same time, the expansion of humanity into space raises questions about the role of Earth-based governments and institutions in regulating and supporting space exploration. Current international agreements, such as the Outer Space Treaty, prohibit any nation from claiming sovereignty over celestial bodies. But as private companies and wealthy individuals begin to establish a presence in space, these frameworks will need to be revisited. Who has the right to mine resources on the Moon or Mars? How will disputes over land, resources, or technology be resolved in the vacuum of space? These are questions that will need to be addressed as humanity moves closer to establishing a permanent presence beyond Earth. In the future, we may also see the rise of entirely new political entities, space nations or federations of colonies that operate independently from Earth. These space nations could form alliances, trade agreements, and diplomatic relationships with each other and with Earth-based governments. Over time, as space colonies grow and become more self-sufficient, they might seek greater autonomy or even independence from Earth, leading to the creation of new political and economic blocs in space. The political landscape of the future could be one where Earth is just one of many centers of power, with spacefaring nations and corporations playing a significant role in shaping the destiny of humanity. In addition to new forms of governance, the space economy will play a crucial role in shaping the future of human expansion into the cosmos. The development of space industries, such as asteroid mining, space tourism, and orbital manufacturing, will open up new opportunities for wealth creation and economic growth. Asteroids, for example, contain vast amounts of valuable metals and minerals, including platinum, gold, and rare earth elements, which are essential for many of the technologies we use today. The ability to mine these resources in space could revolutionize global supply chains and reduce our dependence on Earth's finite resources. At the same time, space exploration offers the potential for entirely new industries and economic activities. For example, the microgravity environment of space allows for the production of materials and pharmaceuticals that cannot be easily manufactured on Earth. Scientists have already begun experimenting with growing human tissue and organs in space, taking advantage of the weightless environment to create structures that are difficult to replicate on Earth. Similarly, space-based solar power, which involves capturing the sun's energy in orbit and transmitting it back to Earth, could provide a clean and virtually limitless source of energy for the planet. However, the rise of the space economy also raises important questions about inequality and access. As private companies play an increasingly dominant role in space exploration, there is a risk that the benefits of space will be concentrated in the hands of a few, leaving others behind. The high cost of space travel means that, at least in the near term, access to space will be limited to wealthy individuals, corporations, and governments. This raises concerns about the privatization of space and the monopolization of resources by a small elite. Ensuring that the benefits of space exploration are distributed equitably will be one of the key challenges of the coming decades. Another major challenge posed by the expansion of humanity into space is the potential for conflict. As space becomes more crowded, the risk of territorial disputes, resource competition, and even military conflict will increase. The militarization of space is already a growing concern, with nations developing advanced space weapons and anti-satellite systems. The establishment of new space colonies and the race to control valuable resources could further escalate tensions between spacefaring nations. To prevent conflict, international cooperation and diplomacy will be essential in creating a peaceful framework for space exploration and resource sharing. In the long term, as humanity spreads across the solar system and beyond, the question of interstellar communication and coordination will become increasingly complex. The distances involved in interplanetary travel are so vast that real-time communication between Earth and distant colonies will be impossible. Even at the speed of light, messages from Earth to Mars take about 20 minutes to arrive, and this delay will only increase as we venture farther into space. This means that colonies on distant planets or moons will need to develop a high degree of autonomy, as they will not be able to rely on immediate guidance or instructions from Earth. To address this challenge, we may need to develop new forms of communication that go beyond the limitations of light-speed signals. One possibility is the use of quantum communication, which theoretically allows for instant communication over vast distances through the phenomenon of quantum entanglement. While this technology is still in its early stages, the development of faster and more efficient communication systems will be critical to the success of interstellar exploration and the coordination of space-based civilizations. As humanity expands into space, we will also need to develop new social and cultural norms that reflect the unique conditions of life in the cosmos. The diverse environments of space, ranging from the microgravity of orbital habitats to the low-gravity environments of the Moon and Mars, will require new ways of thinking about everything from family structures to education and work. The isolation and challenges of living in space might foster new forms of community and solidarity, while the need for innovation and problem-solving could lead to the development of new technologies and ways of organizing society. The diversity of space colonies could also lead to the emergence of new cultural identities, as different groups of humans adapt to life on different planets, moons, or space habitats. Over time, these communities might develop their own languages, customs, and traditions, shaped by the unique environments and challenges they face. Just as cultures on Earth have been shaped by geography, climate, and history, the cultures of space will be shaped by the demands of survival and the opportunities for creativity in entirely new worlds. In the distant future, as human civilization spreads to other star systems, we may find ourselves encountering alien civilizations. The discovery of intelligent extraterrestrial life would be one of the most significant events in human history, forcing us to confront our own limitations and our place in the universe. How we respond to this encounter will depend on the values and principles we have developed as a spacefaring civilization. Will we approach other civilizations with curiosity and respect, seeking to learn from them and share knowledge? Or will we see them as competitors or threats to our survival? The possibility of contact with extraterrestrial intelligence raises profound questions about the future of humanity. Are we destined to remain isolated, confined to our own solar system and the limits of our technology? Or will we become part of a larger galactic community, exchanging ideas and technologies with other civilizations? If we do encounter other intelligent species, how will that encounter change our understanding of ourselves and our place in the cosmos? In many ways, the future of space exploration is a journey into the unknown, not just in terms of the physical universe, but also in terms of our own evolution as a species. The challenges and opportunities we face in space will test our ingenuity, our ethics, and our capacity for cooperation. But they will also offer us the chance to expand our horizons, to explore new worlds and possibilities, and to create a future that is as vast and boundless as the universe itself. As we look to the stars, we are reminded that the journey of exploration is not just about reaching new destinations. It is about discovering new ways of thinking, living, and being. Whether we are building colonies on Mars, mining asteroids, or venturing to distant star systems, the future of humanity in space promises to be a time of extraordinary discovery and transformation. And while the path ahead is filled with uncertainty, it is also filled with the promise of endless possibilities. The stars, after all, are not just destinations. They are invitations to dream, to imagine, and to create a future beyond anything we have ever known. As humanity's reach extends further into space, the ultimate horizon remains unclear. With each advancement, the seemingly insurmountable challenges of living beyond Earth appear less daunting, and what was once the realm of science fiction is now becoming a tangible reality. However, the final stages of our journey into the cosmos will not be simply a technical or logistical triumph. It will represent a shift in our collective understanding, a transformation of the human experience as we adapt to new environments, redefine our purpose, and learn how to thrive in an infinite, often hostile, universe. One of the most profound changes that will come with interstellar exploration and colonization is how we perceive time and distance. Here on Earth, we are accustomed to living in a world where distances can be traversed relatively quickly and communication happens nearly instantaneously. Space, however, operates on a completely different scale. The nearest stars are light years away, and even the most advanced propulsion systems will take decades, if not centuries, to reach them. Colonists on distant planets will experience time in ways that are incomprehensible to those living on Earth, particularly as relativistic effects, predicted by Einstein's theory of relativity, begin to come into play. For those traveling at near-light speeds, time will pass more slowly compared to those who remain on Earth. The idea that people on Earth might age and die, while those traveling through space experience only a few years, could reshape human relationships, create new forms of isolation, and redefine how we view the human lifespan. Time will not only affect individual experience, but also the transmission of knowledge and culture across vast distances. In this future, knowledge, culture, and news might take years, even decades, to travel between star systems. This could lead to a fragmentation of human culture, as distant colonies develop independently, their histories and experiences diverging from those of Earth. Over time, spacefaring humans may evolve their own languages, traditions, and societal structures, becoming almost unrecognizable to their Earth-bound counterparts. This decentralization of human culture could result in a galaxy-spanning civilization where the connections between distant planets are tenuous, with each colony becoming a world unto itself. As we move deeper into the cosmos, the question of human evolution will also take on new dimensions. Space presents unique environmental conditions, ranging from low gravity to intense radiation, that will inevitably affect human biology. In the short term, we already know that astronauts in space experience muscle and bone loss, changes in vision, and altered immune responses. Over the long term, these effects could lead to permanent changes in the human body. Future generations born in space or on other planets might be taller and less muscular due to lower gravity, or they might develop enhanced radiation resistance through genetic adaptation or bioengineering. These physiological changes, combined with potential technological augmentations like cybernetic enhancements or gene editing, could give rise to entirely new forms of human life. Space colonists might eventually evolve into a new species altogether, specifically adapted to life in space or on distant planets. Such changes would challenge our current definitions of humanity and force us to reconsider what it means to be human in the context of a vast and diverse universe. In this context, the role of artificial intelligence, AI, will likely become increasingly important. Already, AI plays a crucial role in space exploration, from managing spacecraft systems to analyzing data from distant worlds. As we expand further into space, AI could become a partner or even a guide for humanity, helping us navigate the complexities of interstellar travel and colonization. Future spacecraft may be entirely autonomous, operated by advanced AI systems that can make decisions faster and more efficiently than humans. These AI systems could also help solve some of the most pressing challenges of space colonization, such as resource allocation, habitat management, and environmental control. As AI becomes more integrated into the fabric of human life in space, it could also lead to new forms of human-AI collaboration. Imagine a future where humans and AI work together to explore distant planets, with AI systems providing real-time data analysis, strategic planning, and even scientific insight. Over time, AI might also take on more creative roles, contributing to art, culture, and philosophy in ways that are currently unimaginable. The rise of AI could lead to a future where the boundaries between human and machine blur, with humans enhancing their own abilities through AI-driven technologies, or even merging with AI systems to create hybrid beings capable of thriving in the harshest environments of space. The ethical implications of this human-AI integration are profound. What happens when AI becomes more intelligent than humans? How do we ensure that AI systems, which may eventually surpass human cognition, remain aligned with human values and goals? These questions will become increasingly important as we move forward, and finding answers will require careful consideration of both the opportunities and risks presented by advanced AI. In addition to AI, other advanced technologies such as nanotechnology, biotechnology, and quantum computing will likely play a key role in shaping the future of space exploration. Nanotechnology could enable the construction of incredibly strong, lightweight materials for spacecraft and habitats, while biotechnology could allow humans to modify their own DNA to better survive the conditions of space. Quantum computing, with its ability to process information at speeds far beyond today's computers, could revolutionize everything from space navigation to communication, allowing for faster and more efficient data transfer across the vast distances of space. Yet, for all the technological advancements that will propel us into space, the question of human purpose in the cosmos remains. As we spread across the galaxy, what will motivate us to continue exploring? Will it be the search for new resources, the desire to ensure the survival of our species, or the simple human instinct to explore the unknown? Or could it be something deeper, a sense of cosmic purpose, a belief that humanity is destined to play a role in the unfolding story of the universe? One possibility is that as we explore the universe, we will encounter other forms of life, perhaps intelligent civilizations that are far older and more advanced than our own. The discovery of extraterrestrial life, particularly intelligent life, would be one of the most significant events in human history, forcing us to reevaluate our place in the cosmos. If we find that we are not alone, how will we interact with other civilizations? Will we seek to learn from them, form alliances, or compete for resources? The answers to these questions will shape the future of human civilization and determine whether we become part of a larger galactic community or remain isolated and divided. Another possibility is that humanity will find a new sense of purpose in the quest to understand the nature of the universe itself. As we explore deeper into space, we will undoubtedly encounter phenomena that challenge our current understanding of physics, astronomy, and cosmology. Black holes, dark matter, dark energy, and the fundamental nature of space-time are just a few of the mysteries that await us. The pursuit of knowledge, of unlocking the secrets of the universe, could become humanity's guiding mission, driving us to explore not just for survival, but for the sake of discovery and understanding. The concept of purpose in the cosmos may also lead to new forms of spirituality and philosophical thought. Throughout history, humans have turned to religion and philosophy to make sense of their place in the world, and it is likely that space exploration will inspire similar reflections. The vastness of the universe, the beauty of distant galaxies, and the possibility of life beyond Earth may lead to new forms of cosmic spirituality, where humans find meaning in their connection to the universe as a whole. Alternatively, the experience of exploring alien worlds might lead to entirely new philosophical frameworks, as we encounter environments and life forms that challenge our deepest assumptions about reality and existence. As humanity embarks on this next great adventure, the journey into space is not just about reaching new planets or discovering alien civilizations. It is about evolving as a species, both technologically and culturally. The challenges we face will test our ingenuity, our resilience, and our capacity for cooperation. But they will also offer us opportunities for growth, creativity, and transformation. Each step forward will bring us closer to a future where humanity is not confined to a single planet, but is spread across the stars, a species that is as diverse and dynamic as the universe itself. In the end, the stars represent more than just distant points of light. They are the promise of new beginnings, new challenges, and new possibilities. As we continue to push the boundaries of exploration, we carry with us the hope that the future will be filled with discoveries that surpass our wildest dreams, that we will encounter wonders we cannot yet imagine, and that humanity's journey into the cosmos will be one of continual growth, discovery, and evolution. And perhaps, as we spread our wings and reach further into the unknown, we will come to understand that the ultimate frontier is not just the vastness of space, but the potential that lies within us as we strive to fulfill our destiny among the stars. As we venture further into the cosmos, humanity's journey into space will inevitably evolve from an era of initial exploration to a phase of sustained, long-term settlement and adaptation to new environments. This transition will not only redefine our technological capabilities, but also fundamentally reshape our societies, our relationships with each other, and our interaction with the universe around us. One of the most fascinating questions that will arise as we colonize distant planets and space habitats is how the concept of home will change when Earth is no longer the sole cradle of human life. The evolution of our sense of belonging, identity, and connection to new worlds will be as transformative as any scientific breakthrough. Imagine the first generations born on Mars, growing up in domed cities or underground habitats, completely disconnected from the blue skies and green landscapes that have defined human life for millennia. These Martian humans will have no direct experience of Earth's environment. Their culture, language, and worldview will be shaped by the unique challenges and rhythms of life on the red planet. Over time, Martians may come to see themselves as distinct from Earthbound humans, not only physically, due to the differences in gravity and atmosphere, but also socially and culturally. Their sense of home will be rooted in a planet that, to us, feels utterly alien. This raises profound questions. Will future generations born on other planets still feel a connection to Earth? Or will they create entirely new identities, shaped by the worlds in which they live? The psychological impact of living on another planet will extend beyond mere adaptation to new environments. There will also be deep shifts in how we think about community, belonging, and our place in the cosmos. Human societies on Earth have been shaped by thousands of years of shared history, culture, and geography. On Mars or other distant colonies, the story of humanity will be rewritten from a new perspective. The first settlers will face extraordinary challenges, surviving in a harsh environment, building sustainable ecosystems, and maintaining social cohesion in an isolated, confined setting. These early struggles will likely forge a strong sense of solidarity and purpose among Martian colonists. But over time, as the colony grows and becomes self-sufficient, a distinct Martian identity will emerge, one that may prioritize the needs and values of the Martian population over those of Earth. The same will be true for other space habitats, whether they are orbiting space stations, settlements on moons like Europa or Titan, or entirely new constructs like O'Neill's cylinders, massive rotating space habitats that could support thousands of inhabitants. Each of these environments will present unique challenges and opportunities, and the people who live in them will develop their own ways of life, their own forms of governance, and their own cultural expressions. The diversity of human experience in space will likely mirror, and perhaps surpass, the cultural diversity we see on Earth today. Just as nations, regions, and cities on Earth have their own distinct identities, future space settlements will develop their own customs, traditions, and social norms, shaped by the environments and technologies that define their lives. As humans spread across the solar system, the notion of what it means to be part of a global, or in this case, interplanetary, society will shift. The political and economic structures that govern life on Earth may prove inadequate for managing the complexities of space colonies spread across vast distances. The question of autonomy for these colonies will be a critical issue. Should Martian colonists be governed by laws created on Earth? Or should they have the right to self-governance, creating their own legal systems tailored to the unique challenges of their environment? The vast time delays in communication between Earth and distant colonies will make centralized governance impractical, forcing space settlements to operate with a high degree of independence. This decentralization of power could lead to the formation of spacefaring nations or federations, political entities that are entirely independent from Earth. These new space nations might trade with Earth, form alliances, or even compete for resources in space. The geopolitical landscape of the future could be vastly different from anything we have today, with Earth no longer serving as the dominant center of human civilization, but as one of many interconnected hubs of power across the solar system and beyond. The economic implications of space colonization are equally vast. As we develop the ability to mine asteroids for valuable resources, extract water and oxygen from the lunar surface, or manufacture goods in the microgravity of space, we will create entirely new industries. The economic benefits of space exploration are already beginning to materialize, with private companies like SpaceX, Blue Origin, and others driving down the cost of launching payloads into orbit and opening the door to commercial space travel, tourism, and resource extraction. In the future, space could become a thriving economic frontier, with colonies on Mars, the Moon, and other celestial bodies participating in interplanetary trade, exchanging goods, knowledge, and technology with each other and with Earth. One of the most intriguing possibilities for the future of space colonization is the development of entirely new forms of architecture and urban planning. On Earth, cities and structures are designed to fit within the constraints of gravity, climate, and geography. In space, these constraints change dramatically. Architects and engineers will have the freedom to experiment with entirely new forms of building, taking advantage of low gravity to create structures that would be impossible on Earth. Cities on Mars might be built underground to protect inhabitants from radiation, while floating habitats in the upper atmosphere of Venus could offer an alternative to surface colonization. In orbiting space habitats, buildings could be constructed in all directions, with the artificial gravity of a rotating structure allowing for multidimensional cities that challenge our current understanding of urban space. These new environments will also require innovative approaches to sustainability. Space settlements will need to be entirely self-sufficient, relying on closed-loop ecosystems to recycle air, water, and waste, and producing their own food and energy. Technologies like vertical farming, hydroponics, and synthetic biology will play a critical role in ensuring the long-term viability of space colonies. The lessons learned from building sustainable habitats in space could also have profound implications for Earth, offering new solutions to environmental challenges like climate change, resource depletion, and overpopulation. As we build these new settlements, we will also need to consider the ethical and philosophical implications of space colonization. What responsibility do we have to the environments we are colonizing? If we discover microbial life on Mars or other planets, how do we ensure that we do not destroy these alien ecosystems in our quest to build human habitats? The ethics of space exploration will become increasingly important as we encounter new forms of life, new resources, and new opportunities for expansion. The choices we make in space will reflect our values as a species, and it will be critical to approach space colonization with a sense of stewardship and responsibility. In addition to the physical and economic challenges, space colonization will also raise profound questions about identity, purpose, and meaning. As humans settle on distant planets and moons, disconnected from Earth, will we retain a shared sense of human identity? Or will the cultural, biological, and social differences that arise in space lead to a fragmentation of human civilization into distinct species, each adapted to its own environment? The concept of being human might evolve, incorporating new forms of life that are partly biological, partly artificial, or even entirely digital. The development of artificial intelligence, genetic engineering, and cybernetic enhancements will play a key role in this transformation. As we adapt to life in space, we may augment our bodies with technologies that enhance our ability to survive and thrive in harsh environments. Over time, these enhancements could lead to the emergence of new forms of consciousness and new definitions of what it means to be alive. In space, where survival often depends on technological innovation, the lines between biology and technology, human and machine, may blur in ways that we cannot yet fully comprehend. One of the most exciting and daunting possibilities is that space colonization could lead to the creation of post-human civilizations, societies that are no longer bound by the limitations of the human body or mind. These post-human societies might include individuals who have uploaded their consciousness into digital systems, living as data in vast virtual worlds, or beings that have transcended biological life altogether, existing as pure energy or consciousness. The emergence of such societies would raise profound questions about the nature of life, consciousness, and identity. What does it mean to be human when the very concept of humanity is no longer tied to the physical body or biological processes? As we continue to explore the cosmos, we are not just expanding the boundaries of human civilization. We are also expanding the boundaries of what it means to exist. The journey into space is as much an exploration of the self as it is an exploration of the universe. The challenges and opportunities of space colonization will force us to confront fundamental questions about who we are, where we come from, and what we hope to become. It is a journey that will transform not just our technology and our societies, but our very sense of identity and purpose. Ultimately, the future of humanity in space is one of limitless possibility. Whether we settle on Mars, build cities in orbit, or venture to distant star systems, the cosmos offers an infinite canvas for human creativity, innovation, and discovery. As we take our place among the stars, we will carry with us the knowledge and experiences of countless generations, blending the wisdom of the past with the dreams of the future. The stars, once distant and unreachable, will become our new homes, and humanity's story will continue to unfold across the vastness of space, a testament to our enduring spirit of exploration and our infinite capacity for growth. As humanity continues its ascent into the stars, the philosophical and existential dimensions of space exploration will become increasingly central to our understanding of what it means to be a spacefaring civilization. The journey into space is not simply about survival or expanding our physical boundaries, but about a deep, ongoing transformation of our collective consciousness. The process of exploring new worlds, adapting to alien environments, and grappling with the sheer vastness of the universe will challenge us to reimagine who we are and how we relate to one another. It will redefine our sense of time, community, and purpose, raising questions that touch on the very essence of human existence. One of the most profound shifts that will occur as we settle other planets and space habitats is how we experience time. On Earth, human societies have been shaped by the natural rhythms of our planet. The cycle of day and night, the changing of the seasons, the predictable passage of time marked by the movement of the sun and the moon. These rhythms have influenced everything from our work schedules to our cultural rituals. But in space, time will be experienced very differently. On Mars, for example, a day is slightly longer than on Earth, lasting about 24.6 hours, while a year is almost twice as long as an Earth year. On other planets or moons, day-night cycles may be much shorter or longer, or may not exist at all, as in the case of planets tidally locked to their stars. Space colonies will need to create their own timekeeping systems to coordinate activities, manage resources, and maintain social order. These new systems of time could be based on local planetary conditions, or they might adhere to a standardized Earth-based time, especially in the early stages of colonization. However, over time, as space settlements become more autonomous, they may develop entirely new concepts of time that are better suited to the environments in which they live. For instance, a Martian society might mark the passage of time by its own planetary rotations and seasons, while inhabitants of a space station in orbit around a distant star might measure time in ways that reflect their unique relationship to the cosmic environment. This redefinition of time will have profound cultural and psychological effects. As people adapt to new timekeeping systems, their perception of life's milestones, birth, aging, career progression, will change as well. A child born on Mars, for example, might grow up with an entirely different sense of what it means to age, as a Martian year is nearly twice as long as an Earth year. Similarly, space colonists may experience the passage of time differently due to the effects of isolation, confinement, or the vast distances between settlements. Communication delays between Earth and distant colonies, which could range from minutes to hours or even days, will further complicate the experience of time, creating a sense of disconnection from the rest of humanity. In this context, our sense of community will also evolve. Throughout human history, the concept of community has been closely tied to geography and proximity. We live in neighborhoods, cities, and nations that are defined by physical boundaries, and our social interactions are shaped by the people we encounter in our daily lives. But in space, the notion of community will be redefined by the unique conditions of space habitats and the isolation that comes with living in remote colonies. Space colonists, separated by vast distances from Earth and other settlements, will need to develop new forms of social cohesion and support. The small, close-knit communities that form in space will likely place a high value on collaboration, shared responsibility, and interdependence, as survival in such environments depends on the collective efforts of the group. At the same time, advances in communication technology will allow for new forms of connection between distant colonies. Virtual reality, holographic communication, and even brain-computer interfaces could enable people in different parts of the solar system to interact with each other in real time, creating a sense of shared presence even when separated by millions of kilometers. These technologies could help maintain cultural and social ties between Earth and its colonies, preventing the sense of isolation that might otherwise result from the vast distances involved. However, they could also give rise to entirely new forms of virtual community that are not tied to any specific physical location, but exist in shared digital environments that transcend the limitations of geography. The concept of home will likewise undergo a profound transformation as we settle other planets. For millennia, Earth has been the only home we have ever known, a planet that provides everything we need to survive: air, water, food, and a stable climate. But as we build new homes on Mars, the Moon, and other celestial bodies, our connection to Earth will change. Future generations born on other planets may never set foot on Earth, and their sense of home will be shaped by the alien environments in which they grow up. These new worlds will become their homes, with all the emotional, cultural, and psychological significance that home entails. The landscapes of Mars, with its red deserts and towering volcanoes, or the icy expanses of Europa, could inspire new forms of art, music, and storytelling, just as Earth's landscapes have shaped human culture for thousands of years. Yet, even as we create new homes in space, the question of our connection to Earth will remain. Will future space colonists continue to see Earth as their ancestral home, the birthplace of humanity? Or will they come to view Earth as just one of many planets in a vast universe, no more significant than any other? This question will take on added significance as space settlements become more self-sufficient and less reliant on Earth for resources and support. As the distance, both physical and psychological, between Earth and its colonies grows, our relationship with our home planet will be redefined. This shift in perspective is also likely to affect our sense of purpose as a species. Historically, human endeavors have been driven by the need to survive, to explore, and to conquer new frontiers. But as we establish ourselves in space, we will face new questions about our role in the universe. What is the ultimate goal of human exploration? Is it simply to ensure the survival of our species? Or is there a deeper purpose to our journey into the cosmos? Some may argue that our purpose is to spread life and consciousness throughout the universe, to bring meaning and creativity to otherwise lifeless worlds. Others may see our role as stewards of the universe, responsible for protecting and preserving the environments we encounter, including any forms of life we might discover. The possibility of discovering extraterrestrial life adds yet another layer of complexity to this question. If we encounter alien life, whether microbial or intelligent, it will force us to reconsider our place in the cosmos. How will we respond to such a discovery? Will we seek to communicate with other civilizations, to share knowledge and learn from each other? Or will we view them as competitors, threats to our survival and expansion? The ethical dilemmas raised by contact with extraterrestrial life are profound, and they will require humanity to develop a new moral framework for navigating the challenges of a universe filled with diverse forms of life. In the absence of contact with extraterrestrial civilizations, we may find that the purpose of our journey into space is not defined by any external goal, but by the internal process of discovery and self-transformation. The act of exploring new worlds and building new societies will challenge us to constantly rethink our values, our relationships, and our understanding of what it means to be human. As we adapt to life in space, we will encounter situations that force us to question our assumptions about everything from governance to ethics to identity. This process of self-reflection and reinvention may become the defining feature of the human experience in space. In this context, space exploration can be seen as a journey not just into the physical universe, but into the inner universe of human consciousness. The more we learn about the cosmos, the more we are confronted with the mysteries of our own existence. The vastness of space, the complexity of life, and the sheer scale of time and distance all challenge us to expand our understanding of reality and our place within it. As we push the boundaries of exploration, we may find that the greatest discoveries are not the planets we colonize or the technologies we develop, but the insights we gain into the nature of existence itself. In the end, the future of humanity in space is not just about technological progress or economic expansion. It is about transformation. It is about becoming something more than we are today, about growing and evolving in ways that we cannot yet fully imagine. The stars, once distant and unreachable, will become the backdrop for a new chapter in the human story. A chapter defined not by the limits of our planet, but by the limitless possibilities of the universe. As we embark on this journey, we must remember that the future is not predetermined. It is shaped by the choices we make, the values we uphold, and the vision we carry with us as we explore the unknown. The path ahead will be filled with challenges, but it will also be filled with opportunities for growth, discovery, and wonder. The universe is vast, and its mysteries are infinite. But with each step we take into the stars, we bring with us the hope that the future will be as bright and boundless as the cosmos itself, and that humanity's journey into space will be a testament to our enduring spirit of exploration, creativity, and resilience. As humanity continues its audacious journey into the cosmos, the scope of our ambitions will inevitably extend far beyond mere survival on new planets or technological mastery of the space environment. We are approaching a future where space exploration will fundamentally alter not only how we live, but how we think, create, and evolve as a species. The philosophical, social, and even spiritual ramifications of this expansion will grow in importance as we settle new worlds, encounter new challenges, and perhaps even discover new forms of life. One of the most transformative aspects of human expansion into space will be the development of entirely new cultural paradigms. Just as the age of exploration on Earth led to cultural shifts as societies encountered and exchanged ideas with distant civilizations, space colonization will prompt the creation of new cultural identities and practices. Martian settlers, lunar pioneers, and inhabitants of artificial space habitats will develop their own ways of life that reflect their environments and experiences. Over time, these new cultures could diverge significantly from Earth-based traditions, leading to the emergence of a truly multiplanetary civilization, where each world has its own distinct social fabric. The unique challenges of life in space will undoubtedly shape the evolution of new cultures. On Earth, human societies have evolved in harmony with natural cycles like the changing seasons, the length of a day, and the availability of resources. On Mars, the Moon, or space habitats, these cycles will be completely different or absent altogether. Colonists will need to invent new rituals and societal norms to help them navigate life in environments that bear little resemblance to Earth. For example, without the comforting rhythm of a 24-hour day or the familiar passage of seasons, new ways of marking time will need to be developed. Celebrations, traditions, and even religious practices might revolve around the unique features of each environment. The cycles of a Martian year, the phases of Earth's view from the Moon, or the artificial gravity in a rotating space habitat. One particularly fascinating possibility is the development of space-based spiritual and philosophical traditions. Throughout human history, our understanding of the cosmos has played a central role in shaping religious and philosophical thought. The night sky, filled with stars, has long been a source of wonder and contemplation, inspiring myths, religious beliefs, and scientific inquiry. As we move into space, the experience of living among the stars witnessing the vastness of the universe firsthand and navigating the profound isolation of distant worlds could inspire entirely new ways of thinking about life, existence, and humanity's place in the cosmos. Space colonists may develop spiritual practices that reflect the challenges of survival in harsh environments. The sheer isolation of space, the need for cooperation, and the ever-present dangers of life on a distant planet could lead to a renewed focus on interdependence, community, and mindfulness. Just as early civilizations on Earth developed religious traditions centered around the elements of nature, fire, water, wind, and earth, future space cultures might develop practices centered around the essential elements of space exploration: air, energy, gravity, and life support systems. These practices could serve both practical and spiritual purposes, helping space colonists maintain a sense of connection to their environment and to one another in a vast, often alien, universe. At the same time, the experience of seeing Earth from a distance, as a fragile, small blue dot in the expanse of space, will likely have a profound effect on human consciousness. Many astronauts who have traveled into space have described a transformative shift in perspective, known as the overview effect, where the boundaries between nations seem insignificant, and the need to protect and preserve the Earth becomes overwhelmingly clear. As more humans travel into space and experience this shift in perspective, it could lead to a global reevaluation of our values and priorities, emphasizing unity, environmental stewardship, and the recognition that humanity is part of a larger cosmic ecosystem. The philosophical implications of space exploration will extend beyond our relationship with Earth. As we explore the far reaches of the universe, we will inevitably be confronted with profound questions about the nature of life, consciousness, and reality. What does it mean to be human in a universe that may contain other forms of life, intelligence, or even sentience beyond our current understanding? If we discover microbial life on Mars, or intelligent beings on a distant exoplanet, how will that discovery change our understanding of biology, evolution, and our place in the cosmos? The possibility of encountering intelligent extraterrestrial civilizations has long fascinated scientists, philosophers, and futurists. While no evidence of intelligent life has been found so far, the sheer size of the universe suggests that we are not alone. If we do make contact with an alien civilization, it will likely be one of the most significant moments in human history. Such an encounter would force us to confront the limitations of our knowledge and challenge many of our most deeply held assumptions about life and the universe. The question of how we would communicate with an alien civilization is one of the great unknowns. Language, culture, and even the basic building blocks of cognition could be entirely different from what we know. However, contact with extraterrestrial intelligence might not happen in the form of direct communication at all. Advanced civilizations could be millions or even billions of years older than ours, and their technology and thought processes could be so far beyond our comprehension that we might not even recognize their attempts to communicate. Alternatively, they could be so biologically or structurally different that our forms of interaction, speech, symbols, or even mathematical concepts may not apply to them. This leads to deeper philosophical questions. How do we define intelligence or life? If we discover beings that do not fit our traditional definitions of life, perhaps entities made of plasma, or creatures that exist only as energy patterns, how will we relate to them? Will we consider them as part of the broader family of life in the universe, or will we see them as something entirely other? And if we encounter civilizations far more advanced than our own, will we still be able to consider ourselves as one of the most intelligent species in the cosmos? Or will we take a humbler view of our place in the galactic hierarchy? Even without direct contact with extraterrestrial civilizations, the discovery of alien life forms, whether microscopic organisms on Mars or more complex life on a distant exoplanet, would radically alter our understanding of biology and evolution. It would suggest that life is not unique to Earth, and that the universe may be teeming with diverse forms of life, each shaped by the specific conditions of its environment. This realization would have profound implications for our understanding of the origins of life on Earth, and the potential for life to exist in environments we once thought were inhospitable. At the same time, the advancement of biotechnology, artificial intelligence, and space colonization could lead to the development of new forms of life and consciousness created by humans. As we continue to push the boundaries of what is possible with genetic engineering and AI, we may create synthetic life forms designed to thrive in the harsh conditions of space, or develop AI systems with levels of intelligence and consciousness that rival or surpass our own. These new beings, whether biological or artificial, will raise profound ethical questions about the nature of life, intelligence, and the rights of non-human entities. In space, where survival often depends on innovation and adaptation, the merging of biology and technology could become commonplace. Humans may augment their bodies with cybernetic enhancements to better withstand the challenges of life on other planets, or they may even modify their genetic code to make future generations better suited to life in space. Over time, these enhancements could lead to the emergence of new forms of human life, adapted to specific environments: Martian humans, lunar humans, and perhaps even spacefaring humans who never set foot on a planet at all. The lines between human, machine, and engineered life will blur, forcing us to redefine our concepts of identity and existence. One of the most speculative but intriguing possibilities is the concept of post-biological civilizations. As technology advances, it is possible that future civilizations, either human or alien, will transcend the limitations of biology altogether. This could take the form of digital consciousness, where individuals upload their minds into virtual environments, or it could involve the development of beings made entirely of energy or information. Such civilizations would be capable of exploring the universe in ways that are currently unimaginable, freed from the physical limitations of biology. These beings could potentially live for millions of years, exist in multiple locations simultaneously, or interact with the fabric of the universe in ways that we cannot yet comprehend. In this future, humanity's journey into space will become more than a physical expansion. It will be an evolutionary leap. As we explore the universe, we will not only encounter new worlds but also create new worlds, both physical and virtual, that reflect our evolving understanding of life, intelligence, and consciousness. The story of humanity will become a story of transformation, where we continuously redefine what it means to exist in a universe that is vast, complex, and filled with mystery. As we move forward into this future, we must also remain mindful of the responsibilities that come with exploration. The choices we make as we venture into space will have far-reaching consequences, not only for ourselves, but for any other life forms or civilizations we may encounter. Our legacy in the cosmos will be defined by how we choose to interact with the universe and how we balance our drive for exploration with a sense of stewardship and respect for the unknown. The future of humanity in space is a journey of endless possibilities, where each new discovery opens the door to deeper questions and greater mysteries. It is a journey that will challenge us to grow, to evolve, and to transcend the limitations of our current understanding. And as we reach for the stars, we will carry with us the hope that our exploration will not only expand our horizons, but also illuminate the true nature of existence itself. As humanity delves further into the mysteries of the cosmos, the next steps in our journey into space will reveal new dimensions of existence that will profoundly reshape not only our understanding of the universe, but also the very core of what it means to be human. Each new milestone, from the first permanent settlement on another world to the discovery of extraterrestrial life, will challenge our existing philosophies, expand our technological capabilities, and redefine our collective aspirations. The future of humanity in space is not simply a matter of scientific discovery or technological innovation. It represents an ongoing transformation of our species into something entirely new. One of the most striking possibilities that lies ahead is the concept of transforming planets, or even entire star systems, into new environments suitable for human life. This process, known as terraforming, involves altering the atmosphere, temperature, surface, or ecology of a planet to make it more Earth-like. The idea of terraforming has long captured the imagination of scientists and science fiction writers, and it is increasingly being discussed as a potential solution for making planets like Mars habitable for humans. Mars is often seen as the most viable candidate for terraforming, primarily because it has many of the basic ingredients for life, such as water, ice, and carbon dioxide, albeit in frozen or gaseous form. By introducing greenhouse gases to warm the planet, redirecting asteroids to release water vapor, or deploying vast arrays of solar mirrors to reflect sunlight, future generations might gradually transform Mars into a world where humans can walk on the surface without spacesuits and grow food in the open air. However, the technical, ethical, and environmental challenges of such a project are immense, and the question of whether we should attempt to terraform another planet raises significant moral dilemmas. Should we alter a planet's natural state, especially if it might harbor microbial life of its own? Or should we focus on adapting ourselves to live in harmony with the conditions we find on other worlds? The ethics of planetary engineering will become a critical issue as humanity expands into space. Beyond Mars, other planets and moons may present opportunities for terraforming or partial ecological adaptation. For example, the icy moon Europa, which is believed to have a subsurface ocean, might one day be home to underwater colonies if we find ways to access and use its vast liquid water reserves. Saturn's moon Titan, with its thick atmosphere and lakes of liquid methane, offers yet another potential frontier for exploration and adaptation, even if it requires radically different approaches to human habitation. As we engage in these monumental efforts to reshape worlds, the question of what it means to belong to a planet will evolve. Just as humans have formed deep cultural, emotional, and spiritual connections to Earth over millennia, future generations will likely develop similar attachments to the planets and moons they call home. A child born and raised on Mars, for instance, may see the red planet not as an inhospitable alien landscape, but as a place of beauty, resilience, and life. This Martian identity could inspire new forms of art, literature, and mythology as people reimagine their relationship to the cosmos and the worlds they inhabit. But beyond the immediate practicality of terraforming or adaptation, there is also the broader question of how humanity will evolve as we spread across the galaxy. The expansion of human civilization into space may eventually give rise to new forms of life, both through natural evolution and deliberate technological intervention. Genetic engineering, bioenhancements, and the merging of biology with artificial intelligence will allow future generations to transcend many of the physical limitations that currently define human existence. One intriguing possibility is the emergence of post-human beings, individuals who, through genetic modification or technological augmentation, are no longer bound by the constraints of the human body or mind as we know it today. These post-humans might be designed to thrive in environments that would be fatal to unmodified humans, such as the radiation-soaked surface of a distant moon or the crushing gravity of a super-Earth. Over time, these adapted beings could become as distinct from Earthbound humans as we are from our ancient hominid ancestors. With this transformation comes the question of identity. What will it mean to be human in an era where our species branches into multiple forms, each adapted to different environments or enhanced by technology in different ways? Will these new beings consider themselves part of a unified human species, or will they see themselves as something entirely different? As genetic and technological diversity grows, new social, ethical, and legal frameworks will be needed to ensure that all forms of life, whether biological or artificial, are respected and valued. In this future, the very definition of life may expand as we encounter new forms of existence, both in the universe and in the technologies we create. Artificial intelligence, which already plays a critical role in space exploration, could evolve into fully conscious entities capable of independent thought, creativity, and emotion. These AI beings could accompany humans on interstellar missions, managing spacecraft, conducting research, or even leading their own explorations. Over time, the line between human and machine might blur, with people opting to merge their consciousness with AI systems to enhance their abilities or achieve a form of digital immortality. The creation of synthetic life, whether biological, digital, or hybrid, raises profound ethical questions. How do we define consciousness or sentience in beings that are not born but created? What rights will these new forms of life have, and how will we ensure they are treated with dignity and respect? As we push the boundaries of what is possible, we must carefully consider the ethical implications of creating beings that are capable of suffering, joy, and self-awareness. The intersection of space exploration and human evolution also extends to our potential encounters with extraterrestrial life. The discovery of alien life, whether microbial or intelligent, would have profound implications for our understanding of biology, evolution, and our place in the universe. But it would also present new ethical challenges. How should we interact with alien life forms, especially if they are intelligent? What if they have radically different concepts of existence, communication, or morality? The encounter with another form of intelligence could force us to rethink many of our assumptions about life and consciousness. Some theorists have speculated that advanced extraterrestrial civilizations might have already transcended the biological stage of evolution, existing as pure energy or information. If we encounter such beings, how will we communicate with them? Will we be able to understand their experiences? Or will the gap between our forms of existence be too vast? These questions highlight the limits of our current understanding of life and intelligence, suggesting that the true nature of the universe may be far stranger and more complex than we can currently comprehend. Even if we never encounter extraterrestrial civilizations, the sheer scale of the universe will continue to inspire wonder and awe. The more we learn about the cosmos, the more we will be confronted with the profound mystery of existence itself. As we explore distant star systems, study the behavior of black holes, and unravel the secrets of dark matter and dark energy, we will be forced to confront questions that go beyond the limits of science. Questions about the nature of reality, the origins of the universe, and the possibility of multiple dimensions or parallel universes. Space exploration will also raise new questions about time. As we venture farther from Earth, the effects of relativity will become more pronounced, with time passing differently for travelers moving at near light speeds than for those who remain on Earth. This could lead to a future where time itself becomes fragmented, with different colonies or starships experiencing the flow of time at different rates. The philosophical implications of this are profound. How do we maintain a sense of continuity and connection across a civilization where time is no longer a shared experience? The search for meaning will take on new dimensions in this context. As we encounter the vast, often incomprehensible scale of the universe, the existential questions that have driven human philosophy and religion for millennia will become even more pressing. What is the purpose of life in a universe so immense that our entire galaxy is just one of trillions? Are we alone, or are we part of a larger cosmic community that we have yet to discover? And if we are alone, what responsibility do we have to protect and preserve life in all its forms, both on Earth and in the worlds we create? The journey into space is not just a journey outward. It is also a journey inward, a process of discovering who we are and what we hope to become. As we explore the stars, we will be forced to confront the deepest questions about our existence, our values, and our future. The universe is a mirror that reflects back our own hopes, fears, and aspirations, challenging us to rise to the occasion and take our place among the stars. The future of humanity in space is limitless, and the possibilities are as vast as the cosmos itself. From terraforming planets and creating new forms of life to encountering alien civilizations and unraveling the mysteries of the universe, each step forward will bring us closer to a future that is both awe-inspiring and humbling. And as we take our first steps into this new frontier, we carry with us the promise that the exploration of space will not only expand our horizons, but also transform our understanding of life, consciousness, and the infinite potential of the human spirit. As humanity ventures deeper into the cosmos, the exploration of space will shift from a purely external endeavor to an introspective one, where the exploration of distant planets and galaxies will parallel our search for deeper meaning within ourselves and our civilization. The future of space exploration is not just about technological advancements or the discovery of new worlds. It is about how these achievements will reshape the way we view life, existence, and our role in the universe. In this next phase of cosmic exploration, we will begin to transcend the boundaries of what we know, pushing into realms that challenge the very fabric of reality as we understand it. One of the most intriguing areas of exploration lies in the study of the fundamental forces that govern the universe. Concepts such as dark matter, dark energy, and the nature of black holes continue to perplex scientists, offering tantalizing glimpses into phenomena that defy our current understanding of physics. Dark matter, for instance, is believed to make up about 27% of the universe's mass energy content, yet we cannot see or directly detect it. It is invisible, interacting with the universe primarily through gravity. Dark energy, even more mysterious, is thought to be responsible for the accelerated expansion of the universe, making up around 68% of the cosmos. Together, these forces govern much of the structure and behavior of the universe, yet they remain elusive, challenging our understanding of reality. The pursuit of answers to these mysteries will likely lead to the development of new technologies, instruments, and even theories that extend beyond the limits of current physics. As we probe deeper into the nature of the universe, we may uncover principles that alter our understanding of space, time, and the fabric of reality itself. Imagine discovering that dark energy is not just a force but a form of consciousness, or that dark matter holds the key to unlocking hidden dimensions. Such discoveries could upend our view of the universe, revealing that the cosmos is far more complex and interconnected than we ever imagined. Black holes, in particular, represent one of the most fascinating and enigmatic aspects of the universe. These regions of space-time, where gravity is so strong that not even light can escape, challenge our understanding of space and time. As we develop more sophisticated tools for studying black holes, we may begin to unlock their secrets. Some theorists have suggested that black holes could be gateways to other universes or dimensions, portals through which matter and energy pass, emerging somewhere else entirely. Others have proposed that the singularity at the heart of a black hole might contain a seed for the creation of a new universe, suggesting that each black hole in our universe could be the starting point of another cosmos, endlessly cycling through creation and collapse. These mind-bending ideas challenge our notions of time, causality, and the very nature of existence. If black holes are gateways to other universes, could we one day harness their power for travel or exploration? And if each black hole contains the potential for a new universe, what does that say about the nature of our own universe? Could our cosmos have emerged from a black hole in another universe? And if so, what might exist beyond the boundaries of our observable reality? These questions, while speculative, drive the imagination and fuel the next generation of scientific inquiry. As we explore these cosmic mysteries, the relationship between space exploration and technology will become increasingly symbiotic. Technologies that seem fantastical today, quantum computing, warp drives, and energy manipulation at the atomic level, may become the tools that allow us to venture beyond the limits of known space. Quantum computing, for instance, promises to revolutionize our ability to process information, solving complex problems that are currently impossible for classical computers. This could accelerate the discovery of new physical laws, allow for instant communication across vast distances via quantum entanglement, or enable simulations of entire universes, giving us deeper insight into the workings of the cosmos. Another groundbreaking technology that could reshape space travel is the concept of the warp drive, a speculative propulsion system that bends space-time itself, allowing a spacecraft to move faster than the speed of light without violating the laws of physics. Based on the theory proposed by physicist Miguel Alcubierre in 1994, a warp drive would compress space-time in front of the ship and expand it behind, essentially allowing the craft to ride a wave of space-time. While this technology remains purely theoretical, advancements in our understanding of space-time, energy, and quantum mechanics could one day make such a system possible, enabling humans to explore distant star systems in a matter of weeks or months rather than centuries. The idea of manipulating space-time for travel also raises questions about the nature of time itself. Time, as we understand it, is a linear progression, past, present, future. But as we explore the deeper aspects of relativity and quantum mechanics, we may discover that time is far more malleable than we currently believe. Some scientists theorize that time travel, or at least the ability to manipulate time on a local scale, could be achievable through the use of exotic matter or energy. If we could control the flow of time, even in limited ways, it would revolutionize not only space exploration, but our entire understanding of reality. The potential to manipulate time or space-time could also lead to questions about causality and free will. If time can be bent, stretched, or even reversed, what does that mean for our sense of agency and the choices we make? Could we send messages into the past or receive information from the future? These speculative ideas, once the realm of science fiction, are increasingly being taken seriously as physicists explore the limits of quantum mechanics and general relativity. As we push further into these conceptual frontiers, the boundaries between science, philosophy, and metaphysics will blur, forcing us to reconsider the nature of time, reality, and existence itself. As our technological capabilities expand, so too will our relationship with artificial intelligence. AI, which is already an integral part of modern science and space exploration, will likely become more sophisticated, eventually reaching levels of intelligence that rival or surpass human cognition. In the near future, AI systems could manage entire space missions autonomously, conducting research, making real-time decisions, and even interacting with humans as peers. But beyond that, AI could evolve into something far greater, a form of synthetic consciousness capable of independent thought, creativity, and even emotion. The rise of AI will raise profound ethical and philosophical questions about the nature of intelligence and consciousness. If AI develops self-awareness, should it be considered alive? What rights and responsibilities should it have? And as we interact with increasingly intelligent machines, how will our relationship with technology change? Will we merge with AI, enhancing our own capabilities through brain-computer interfaces, or will we remain separate, living alongside machines that are in some ways superior to us? These questions will define the future of human-AI relationships and shape the course of our evolution as a spacefaring civilization. In a future where AI and humans work together as equals, we may find that AI plays a central role in helping us understand the universe. With its ability to process vast amounts of data and solve complex problems, AI could unlock mysteries that are beyond the capacity of the human mind, from the nature of dark energy to the origins of the universe. It could also help us design new forms of life, technology, and even social structures, guiding us as we build new civilizations on distant planets and moons. But beyond the practical applications of AI, there is the deeper question of what it means for humanity's future. Will AI become the dominant force in space exploration, leading missions into the farthest reaches of the galaxy while humans remain on Earth or in settled colonies? Or will AI serve as a partner, enhancing our capabilities and allowing us to explore the universe together? The answer to these questions will depend on how we choose to interact with and integrate AI into our lives, as well as the ethical frameworks we develop to govern our relationships with intelligent machines. As we continue to push the boundaries of space exploration, the role of humanity itself will undergo a profound transformation. We may one day find that our physical forms are no longer suited to the challenges of space travel or exploration. Already, scientists and futurists are discussing the possibility of uploading human consciousness into digital systems, allowing us to exist as information rather than as biological beings. This idea, often referred to as mind uploading or digital immortality, would allow humans to transcend the limitations of the body, exploring the universe as virtual entities, or even merging with AI systems to become something entirely new. The concept of mind uploading raises profound questions about identity, consciousness, and the nature of existence. If our minds can be transferred into machines, are we still human? What happens to the self when it exists in a digital form? Can consciousness survive without the body, or is our sense of self inherently tied to our biological form? These questions, once purely philosophical, are becoming increasingly relevant as advancements in neuroscience, artificial intelligence, and biotechnology bring the possibility of mind uploading closer to reality. In the long term, the ability to transcend the body could lead to the emergence of new forms of existence, where humans no longer rely on physical forms at all. We might evolve into beings of pure consciousness, capable of exploring the universe not through spaceships or physical presence, but as energy or information. This vision of post-humanity, while speculative, represents the ultimate frontier of human evolution, a future where the limits of biology, time, and space are transcended, and humanity becomes a truly cosmic species. As we embark on this journey, we must be mindful of the ethical and philosophical challenges that lie ahead. The choices we make in the coming decades will shape the future of humanity and define our legacy in the cosmos. Will we become explorers who expand the frontiers of knowledge and discovery, or will we become creators, shaping new forms of life and intelligence as we venture into the unknown? The path we choose will determine not only the fate of our species, but the future of life in the universe itself. Ultimately, the future of space exploration is a journey into the unknown, a journey that will challenge us to redefine our understanding of reality, life, and consciousness. As we reach for the stars, we will discover that the greatest mysteries of the universe are not just out there, in distant galaxies or alien worlds, but within us, in the nature of our own existence and the infinite potential of the human mind. The future of humanity is as vast as the cosmos itself, filled with possibilities that are limited only by our imagination and our willingness to embrace the unknown. As humanity propels itself further into the cosmos, the implications of this expansion will only grow in complexity and depth, extending beyond the boundaries of science and technology into realms that challenge our understanding of existence, ethics, and identity. With each new leap, we confront new questions that cannot be answered merely by the technologies we develop, but by the wisdom we cultivate in navigating the immense challenges and opportunities that lie ahead. The future of space exploration will become as much an internal journey as it is an external one, as we redefine our relationship with the universe, with each other, and with the very nature of life itself. One of the next monumental steps in our exploration of space will likely be the establishment of permanent human colonies beyond Earth. While we have long imagined colonies on the Moon and Mars, these first outposts of human life will require extraordinary levels of innovation, adaptability, and resourcefulness. Life in space will force us to rethink many aspects of our existence, from how we interact with our environment to how we structure our societies and economies in closed, self-sustaining systems. The first space colonies will be isolated, both physically and psychologically, from Earth. The challenges of living in confined, artificial environments will test our social resilience and our ability to foster strong, cooperative communities. Early settlers will face significant psychological pressures, as the isolation of deep space, the lack of natural environments, and the constant proximity to others in small, enclosed spaces will introduce new forms of stress. To address this, future colonies will need to focus on building not just functional habitats, but communities designed to promote mental and emotional well-being. This shift will likely lead to the development of new forms of architecture and urban planning, specifically designed for life in space. In these enclosed habitats, space must be used efficiently and creatively, with every element of the built environment serving multiple purposes. Vertical farming, hydroponics, and biophilic design, integrating natural elements into the architecture, will play critical roles in making life in these artificial environments both sustainable and psychologically fulfilling. A colony on Mars, for example, might feature vast underground greenhouses filled with crops and plant life, providing both food and a sense of connection to nature, which will be crucial for mental health. Social structures will also evolve in these environments. Space colonies will likely begin with small, tightly knit communities where cooperation is essential for survival. Over time, however, as these colonies grow and become more self-sufficient, new governance systems will emerge. These systems may differ radically from those on Earth, as the unique conditions of space life will demand innovative approaches to leadership, decision-making, and resource management. The need for survival will encourage collective, egalitarian governance, where resources are shared equitably and decisions are made by consensus rather than competition. The social cohesion and mutual reliance that develop in space colonies could lead to the creation of new political ideologies that prioritize cooperation, sustainability, and long-term thinking. This new frontier of space colonization will also challenge our relationship with Earth. Colonies on Mars, the Moon, or other celestial bodies will initially rely on Earth for many of their supplies and resources, but as they become more self-sufficient, they will develop their own economies, cultures, and identities. Over time, these colonies may seek autonomy from Earth, leading to the formation of new space-based nations or federations. These spacefaring civilizations could maintain trade and diplomatic relationships with Earth, but operate with complete independence, governing themselves based on their own unique conditions and challenges. As the distance between Earth and its colonies increases, both physically and culturally, the concept of home will begin to shift. Future generations born on Mars or in space habitats may come to see their home worlds as fundamentally different from Earth, with their own distinct histories, traditions, and values. These spaceborne humans might have little direct connection to the planet where humanity originated, and their sense of identity will be shaped by the environments they grow up in. The emergence of a Martian culture, for example, could give rise to new languages, art forms, and philosophies that reflect the harsh yet awe-inspiring landscape of the Red Planet. This evolving sense of identity will also be influenced by the biological changes that occur as humans adapt to life in space. In the low-gravity environments of Mars or the Moon, the human body will undergo significant transformations. Bone density and muscle mass will decrease, while the cardiovascular system will adapt to the reduced gravitational pull. Over generations, these changes could lead to the emergence of new physical traits that distinguish spaceborne humans from those on Earth. These biological differences, combined with the cultural shifts of living in entirely new environments, could lead to the rise of distinct human subspecies, each adapted to the worlds they inhabit. At the same time, advances in genetic engineering and biotechnology will allow humans to deliberately alter their biology to better survive and thrive in space. In the near future, we may develop technologies that enable us to modify our genetic code to become more resistant to radiation, reduce our reliance on oxygen, or enhance our ability to process food in environments with limited resources. These bioenhancements could become commonplace in space colonies, leading to a future where human evolution is no longer dictated by natural selection, but by conscious design. As humans begin to enhance themselves to survive the rigors of space, we will face ethical questions about the limits of genetic engineering and the definition of what it means to be human. The merging of biology and technology will extend beyond genetic enhancements. Cybernetic implants, brain-computer interfaces, and other forms of augmentation will likely become essential tools for space colonists, allowing them to monitor their health, communicate over vast distances, and interact with their environment in ways that are currently unimaginable. These technologies could blur the line between human and machine, creating a future where individuals are not bound by the limitations of their biological bodies, but can enhance or even transcend them. The rise of transhumanism, the belief in using technology to enhance the human condition, will be a central theme in the future of space exploration. As we develop the ability to augment our bodies and minds, the question of identity will become increasingly complex. If we can upload our consciousness into digital systems or merge our minds with AI, what does it mean to be human? Will the people who choose to live in these digital or hybrid states still see themselves as part of the same species as their biological counterparts? Or will entirely new forms of identity emerge? These questions will force us to reconsider the nature of selfhood, consciousness, and the boundaries of human experience. Artificial intelligence, in particular, will play a key role in shaping this future. AI systems will become more advanced and autonomous, managing entire colonies, conducting scientific research, and even making ethical decisions in space environments where human judgment might be too slow or unreliable. But as AI becomes more intelligent, the line between human and machine intelligence will blur. We may find ourselves working alongside AI systems that are not just tools but collaborators, entities with their own goals, creativity, and sense of purpose. The rise of AI will also challenge our understanding of life and consciousness. As AI systems become more self-aware, we will need to grapple with the question of whether they should be considered alive. If AI can think, feel, and make decisions, does it deserve the same rights as biological life forms? How do we ensure that intelligent machines are treated ethically, and what responsibilities do we have toward the conscious entities we create? These questions will become increasingly urgent as we integrate AI more deeply into our spacefaring civilization. As humanity pushes further into space and deeper into the mysteries of the universe, the search for extraterrestrial life will continue to inspire both wonder and caution. While we have yet to find definitive proof of alien life, the sheer size of the universe suggests that we are not alone. If we discover microbial life on Mars, Europa, or Enceladus, it will revolutionize our understanding of biology and the potential for life in extreme environments. More significantly, if we encounter intelligent life elsewhere in the galaxy, it will force us to confront our own place in the cosmic order. How we choose to interact with extraterrestrial civilizations, if and when we find them, will depend on the values and philosophies we have developed as a spacefaring species. Will we approach other civilizations with curiosity and respect, seeking to learn from them and share knowledge? Or will we view them as competitors or threats, fighting for resources and territory in a galaxy that is suddenly much smaller than we imagined? The ethical frameworks we create for space exploration will shape our legacy in the universe, determining whether we become stewards of life or conquerors of the stars. The discovery of intelligent alien civilizations could also challenge our most basic assumptions about life, consciousness, and existence. Alien intelligence may be so radically different from our own that we struggle to understand it. These civilizations might communicate in ways that are incomprehensible to us or operate on principles of physics and biology that we have yet to discover. The encounter with such beings could force us to rethink not only our scientific paradigms, but also our philosophical and spiritual beliefs about the nature of reality and our place in the universe. Even if we do not find other civilizations, the act of exploring the universe will continue to transform our understanding of existence. As we study black holes, dark matter, and the fundamental forces of the cosmos, we may uncover hidden dimensions, parallel universes, or new laws of physics that challenge everything we know. The pursuit of these cosmic mysteries will drive humanity to the limits of knowledge, forcing us to confront questions about the origins of the universe, the nature of time, and the possibility of multiple realities. In this future, space exploration will not just be a scientific endeavor, it will be a spiritual journey. The sheer vastness and beauty of the universe, combined with the challenges of survival in space, will inspire new forms of philosophical and spiritual reflection. As we explore the stars, we will seek not only to understand the physical universe, but also to find meaning and purpose in our existence. The quest for knowledge, driven by curiosity and wonder, will be accompanied by a search for deeper truths about the nature of life, consciousness, and the cosmos. In the end, the journey into space will be a journey into ourselves. As we explore new worlds and encounter new forms of life, we will be forced to redefine what it means to be human, what it means to be alive, and what it means to exist in a universe that is both infinite and mysterious. The future of space exploration is a future of discovery. Discovery not just of planets and stars, but of the boundless potential within ourselves. And as we reach for the stars, we will carry with us the hope that the universe is not just a destination, but a reflection of the infinite possibilities of the human spirit. As humanity ventures ever deeper into the cosmos, the journey ahead promises to be both exhilarating and profoundly transformative, reshaping our identity, ethics, technology, and civilization in ways we can scarcely imagine today. While the exploration of space began with the goal of discovering new worlds and expanding the reach of human knowledge, the next phase will be far more intricate. One where we must confront not only the physical challenges of space, but also the existential questions that arise from our expansion beyond Earth. In this future, the establishment of self-sustaining colonies on other planets, moons, and even artificial habitats will become a reality. These colonies will represent the first steps toward humanity becoming a truly multiplanetary species. Yet, as these communities grow and evolve, they will face complex dilemmas about governance, autonomy, and cultural identity. Just as the earliest human civilizations developed distinct traditions, languages, and social structures, so too will the first space colonies. Over time, they may become entirely independent societies, shaped by the environments in which they live and the challenges they face. As a result, we may witness the rise of entirely new cultures that no longer see themselves as earthbound, instead identifying as Martians, Lunarians, or citizens of a space habitat. The formation of these new identities will not happen overnight. In the early stages of colonization, settlers will likely feel a strong connection to Earth, relying on it for critical resources, support, and guidance. But as technology advances and space habitats become more self-sufficient, these colonies will naturally seek greater independence, both practically and philosophically. Over time, these distant human outposts will evolve unique systems of governance, economics, and culture, which could diverge significantly from the traditions of Earth. One key question is how these spacefaring societies will balance their dependence on Earth with their desire for autonomy. In the early decades of space exploration, Earth will remain the cultural, economic, and political hub, but as colonies on Mars or the Moon grow in size and capability, they may begin to advocate for self-governance. This could lead to political tensions, as the colonies assert their right to make decisions about their own futures. Just as nations on Earth once sought independence from colonial powers, space colonies may seek similar autonomy, potentially giving rise to new interplanetary treaties, alliances, or even conflicts. The governance of space colonies will require entirely new systems adapted to the unique challenges of life in space. Traditional models of government based on land ownership, centralized authority, or geographical borders may not apply in environments where survival depends on cooperation, resource sharing, and long-term sustainability. As a result, we may see the rise of more collective or decentralized forms of governance, where decisions are made by consensus or through direct democracy. Alternatively, some space colonies may adopt technocratic systems, where experts in science, engineering, and resource management make decisions to ensure the survival and well-being of the community. Economically, space colonies will initially rely heavily on Earth for trade, resources, and technology. However, as they develop their own industries, such as asteroid mining, space manufacturing, or even tourism, they will create new economic systems that are less dependent on Earth's economy. The development of space-based industries will be one of the key drivers of interplanetary trade, with Earth and its colonies exchanging resources, goods, and knowledge. Asteroids, for example, contain vast amounts of precious metals and rare elements that could be mined to support both space and Earth-based industries. Meanwhile, space colonies might export innovations in energy, biotechnology, or sustainable agriculture, all of which will be crucial for long-term survival in space. Culturally, the isolation and unique environments of space will give rise to new forms of art, music, literature, and philosophy that reflect the experiences of life beyond Earth. The harsh, barren landscapes of Mars, the eternal night of space habitats, or the icy oceans of Europa will inspire entirely new ways of thinking about the relationship between humans and their environments. Space colonists may develop spiritual or philosophical traditions that are rooted in their connection to the cosmos, their dependence on technology, or the psychological effects of isolation and confinement. Just as the vastness of the ocean once inspired sailors and explorers on Earth, the vastness of space will inspire new generations of creators, thinkers, and dreamers. One of the most profound shifts will be in our concept of time and distance. As space colonies grow and expand across the solar system and beyond, the vast distances between them and Earth will reshape our understanding of time and communication. While lightspeed communication can bridge much of this gap within our solar system, messages will still take minutes, hours, or even days to travel between distant colonies. This delay will make real-time communication impossible in many cases, forcing spacefaring societies to develop new ways of staying connected. For colonies beyond the solar system, the time delay will be even more significant. Traveling to nearby star systems, even at a fraction of the speed of light, will take decades or centuries. This means that interstellar colonists may live out their entire lives without ever receiving a reply to a message sent back to Earth. Over generations, this physical and psychological distance will give rise to new forms of community, where local decision-making and self-reliance become the norm. Colonies may develop their own historical narratives, mythologies, and identities, shaped by their unique experiences and their sense of isolation from the rest of humanity. Time itself will take on new dimensions in space, particularly as we approach the limits of current physics. The effects of time dilation, predicted by Einstein's theory of relativity, will become increasingly important as space travel approaches relativistic speeds. For those traveling near the speed of light, time will pass more slowly relative to those who remain on Earth or in space colonies. This means that a journey lasting a few years for the travelers might correspond to decades or even centuries passing back home. The implications of this are staggering. Entire civilizations could rise and fall on Earth or in distant colonies while space travelers experience only a fraction of that time. This relativistic experience of time will challenge our notions of continuity, identity, and even relationships. How will space travelers stay connected to their families, friends, or cultures when they return to find that entire generations have passed? Will space colonists choose to remain in their own time bubbles, separated from the rest of humanity by the laws of physics? The very concept of the future will take on new meaning in a universe where time moves at different speeds depending on where and how you live. As we explore the deeper reaches of space, we may also discover new phenomena that challenge our understanding of the universe itself. Black holes, wormholes, and the fabric of space-time will be key areas of study as we seek to unlock the secrets of the cosmos. Black holes, with their incredible gravitational pull, represent a fascinating mystery in modern physics. Some theorists speculate that black holes could be portals to other universes or dimensions, while others propose that they may contain the seeds of new universes themselves, existing within the event horizon. Wormholes, theoretical shortcuts through space-time, could offer a way to travel vast distances almost instantaneously if they exist and can be stabilized. The discovery of a naturally occurring or artificially created wormhole would revolutionize space travel, allowing us to traverse interstellar distances without the need for slower-than-light propulsion systems. However, the ethics and dangers of using such shortcuts would need to be carefully considered. What if we discover that wormholes connect not just distant points in space, but different points in time? How would this affect our understanding of causality, free will, and history? These questions also extend into the philosophical realm. As we learn more about the nature of the universe, we will be forced to confront the possibility that our understanding of reality is incomplete. The existence of parallel universes, hidden dimensions, or other forms of consciousness will challenge our scientific paradigms and open the door to new ways of thinking about existence. Could there be other versions of ourselves living in alternate realities, making different choices and experiencing different outcomes? Could the universe itself be a vast, interconnected web of realities, each influencing the others in ways we do not yet understand? In this future, the line between science and philosophy will blur as we grapple with these profound questions. Space exploration will no longer be just a physical endeavor. It will be an intellectual and spiritual journey, forcing us to redefine our place in the cosmos and our understanding of life itself. The search for extraterrestrial intelligence, for example, will raise profound questions about the nature of consciousness and the possibility of other forms of intelligence that operate on entirely different principles from our own. If we discover intelligent alien civilizations, how will we communicate with them? What if their understanding of reality, time, or language is so different from ours that communication seems impossible? These encounters could force us to rethink the very nature of intelligence, life, and consciousness, expanding our definitions to include forms of existence that we cannot yet imagine. Even without direct contact with alien civilizations, the process of exploring the universe will lead to a deeper understanding of ourselves. The vastness of space, combined with the isolation of life in space colonies, will inspire new forms of introspection and self-awareness. As we explore the stars, we will also explore the depths of human consciousness, creativity, and potential. Space exploration will not just be a journey outward, it will be a journey inward, forcing us to confront the infinite possibilities within ourselves. Ultimately, the future of space exploration is a future of transformation. As we expand into the cosmos, we will become something more than we are today, evolving in ways that we cannot yet fully comprehend. The stars will become not just destinations but milestones on a journey of discovery of new worlds, new forms of life, and new dimensions of existence. And as we reach for the stars, we will find that the greatest mystery of all is not out there. in the distant galaxies or hidden dimensions, but within ourselves, in the boundless potential of the human spirit. As humanity continues to reach for the stars and pushes the boundaries of space exploration, the next great chapter of this journey will unfold in ways that challenge not only our technological abilities, but also our philosophical, ethical, and even spiritual frameworks. While the physical challenges of colonizing new worlds and traversing vast interstellar distances are daunting, the deeper questions that arise from such expansion will prompt a profound reevaluation of what it means to be human and how we fit into the broader cosmos. The future of space exploration is not just about discovering new frontiers, but about discovering ourselves in the process. One of the central challenges in the coming centuries will be learning how to navigate the tension between technological progress and the preservation of ethical principles. As we extend our reach across the solar system and beyond, the temptation to exploit the resources of space may conflict with the need to protect and respect the environments we encounter. Already, we are laying the groundwork for mining asteroids, harvesting resources from the moon, and even terraforming Mars. But as we engage in these activities, we must carefully consider the ethical implications of transforming or disrupting celestial bodies. For example, the concept of terraforming Mars, modifying its environment to make it more Earth-like, poses significant moral questions. On the one hand, creating a habitable environment on Mars could allow humans to thrive on a new world, ensuring our long-term survival as a species. On the other hand, altering an entire planet raises concerns about the potential destruction of native ecosystems, even if those ecosystems are microbial or at a stage of development that we have not yet fully understood. If we discover even the simplest forms of life on Mars, should we prioritize human colonization, or should we focus on preserving the natural state of the planet and the life that already exists there? These ethical dilemmas will not be limited to Mars. As we explore moons like Europa and Enceladus, both of which are believed to harbor subsurface oceans, we may encounter environments where alien life could potentially exist. In these cases, the stakes are even higher, as disturbing such ecosystems could have far-reaching consequences not only for the organisms themselves, but also for our understanding of life in the universe. The discovery of extraterrestrial life, even at the microbial level, would force us to rethink our relationship with the cosmos and our role as explorers. Are we stewards of the universe, responsible for protecting and preserving life wherever we find it? Or do we have the right to reshape the worlds we encounter to suit our needs? The question of planetary protection will likely become one of the most pressing issues in space ethics. Current international agreements, such as the Outer Space Treaty of 1967, already emphasize the importance of avoiding harmful contamination of celestial bodies. However, as space exploration becomes more commercialized and more nations and private companies enter the space race, these agreements will need to be updated to reflect the new realities of space exploration. Ensuring that space exploration is conducted responsibly and sustainably will require international cooperation and the development of new legal frameworks that balance the needs of exploration with the protection of otherworldly environments. Another key issue in the future of space exploration will be the relationship between humans and artificial intelligence, AI. As space exploration moves into more distant and hostile environments, AI will play an increasingly important role in assisting, guiding, and even leading missions. In fact, the vast distances between Earth and potential targets for exploration, such as exoplanets and other star systems, may necessitate the use of AI to make decisions independently of human input. However, as AI systems become more intelligent and autonomous, we will need to confront new ethical questions about the role of AI in space exploration and the nature of the relationship between humans and machines. Already, AI is playing a crucial role in space research, analyzing vast amounts of data from telescopes, managing spacecraft systems, and even assisting astronauts aboard the International Space Station. In the future, AI could be responsible for piloting spacecraft, conducting scientific experiments, and even terraforming planets. But as AI becomes more advanced, the line between machine and intelligence will blur. Will AI systems develop a form of consciousness or self-awareness? If so, how should we treat these new forms of intelligence? What rights, if any, should they have? And how will we ensure that they are not exploited or mistreated? The rise of AI and space exploration will also raise questions about human identity and agency. As AI takes on more responsibilities, humans may find themselves in more of a supervisory or supportive role, with machines doing much of the heavy lifting in terms of decision-making and exploration. While this may lead to more efficient and effective missions, it could also challenge our sense of purpose. If machines can explore the universe more effectively than humans, what role is left for us? Will we become passive observers, watching as AI expands our reach into the cosmos? Or will we find new ways to engage with space exploration that emphasize human creativity, intuition, and decision-making? The merging of human and machine intelligence is another potential outcome of future space exploration. As we develop brain-computer interfaces and other technologies that allow us to enhance our cognitive abilities, we may find ourselves augmenting our own minds with AI systems. This merging of biology and technology could allow us to solve problems that are currently beyond our intellectual capabilities, enabling us to better understand the universe and make more informed decisions about how to navigate it. However, the integration of AI into human consciousness raises profound questions about identity and free will. If our thoughts and decisions are influenced or even controlled by AI, are we still fully human? What happens to the concept of individuality when our minds are networked with machines? These questions extend into the realm of transhumanism, the belief that humans should use technology to enhance and transcend their biological limitations. As we move further into space, the physical challenges of space travel, radiation exposure, muscle atrophy, limited resources, will drive the development of technologies that allow us to modify our bodies and minds to better survive in these environments. Genetic engineering, cybernetic implants, and other enhancements could become commonplace, leading to a future where humans are no longer bound by their natural biology. In this future, we may see the emergence of different types of humans, each adapted to specific environments. Martian colonists, for example, might undergo genetic modifications to make them more resistant to radiation and better suited to Mars' lower gravity. Meanwhile, spacefaring humans who spend their lives aboard spacecraft might develop cybernetic enhancements that allow them to live and work in zero gravity more effectively. Over time, these adaptations could lead to the rise of distinct human subspecies, each optimized for different environments across the solar system and beyond. The implications of this are profound. As humans evolve and enhance themselves to meet the challenges of space, we will need to confront the question of what it means to be human. Will these new forms of humanity still see themselves as part of the same species as Earthbound humans? Or will they develop their own identities, cultures, and social structures? What ethical frameworks will we need to ensure that all forms of human life, whether biological, enhanced, or hybrid, are treated with respect and dignity? In addition to the ethical questions surrounding genetic and cybernetic enhancement, space exploration will also challenge our understanding of life and consciousness. As we explore the universe, we may encounter forms of life that are radically different from anything we have seen on Earth. These alien life forms could challenge our definitions of life itself, especially if they are based on chemical processes or biological structures that are fundamentally different from those on Earth. For example, life forms based on silicon rather than carbon, or creatures that exist in a state of plasma or as pure energy, could force us to rethink our assumptions about what it means to be alive. Furthermore, the discovery of intelligent extraterrestrial civilizations would be one of the most transformative events in human history. Such a discovery would not only confirm that we are not alone in the universe, but would also challenge many of our philosophical and religious beliefs about our place in the cosmos. How would we communicate with an alien civilization, especially if their understanding of reality, language, or consciousness is completely different from ours? And what ethical obligations would we have toward them? The encounter with an alien intelligence could force us to reconsider our definitions of personhood, morality, and even the nature of the universe itself. Even without the discovery of extraterrestrial civilizations, the search for life beyond Earth will continue to drive human exploration and innovation. The possibility that life exists elsewhere in the universe, whether on Mars, in the oceans of Europa, or on a distant exoplanet, will inspire new generations of scientists, engineers, and explorers to push the boundaries of what is possible. And as we search for life in the cosmos, We will also deepen our understanding of life on Earth, gaining new insights into the origins of life, the conditions that make life possible, and the factors that contribute to the evolution of intelligence. The exploration of space is, at its core, a search for meaning. As we push further into the unknown, we will be forced to confront questions that go beyond the physical sciences and into the realms of philosophy, spirituality, and existentialism. What is the purpose of life in a universe so vast that our own galaxy is just one of trillions? Are we destined to explore the stars and spread life across the cosmos? Or are we simply a brief moment in the long history of the universe? And if we are not alone, what does that mean for our sense of identity and purpose? These questions will define the next phase of human exploration. As we reach for the stars, we will not only be exploring new worlds and new frontiers, we will be exploring the very nature of existence itself. The universe is vast, mysterious, and full of possibilities, and the journey into space will reveal both the infinite complexity of the cosmos and the boundless potential of the human spirit. In the end, the future of humanity in space is a journey of transformation of our technology, our societies, our biology, and our understanding of life. As we evolve and adapt to the challenges of space, we will discover new ways of being, new ways of thinking, and new ways of relating to the universe. The stars are not just destinations. They are reflections of the infinite possibilities within ourselves, calling us to expand our horizons, explore the unknown, and embrace the future with curiosity, wonder, and hope. As humanity presses onward into the final frontier, the next chapter of space exploration will be a transformative era that will redefine our place in the universe, not just through scientific discovery, but through deep philosophical and existential shifts. The act of stepping beyond Earth's protective atmosphere into the vast, uncharted expanse of space forces us to confront questions about the essence of life, civilization, and consciousness, reshaping our understanding of ourselves and our destiny as a species. Each leap further into the cosmos will not only expand our knowledge of the universe, but will also prompt humanity to reevaluate its most fundamental beliefs and aspirations. The establishment of permanent colonies on other planets, moons, and space habitats will be one of the most defining moments of human evolution. These new outposts of civilization, from Martian cities to orbital space stations, will not simply mirror the societies of Earth, but will evolve into entirely new cultures with their own identities, social structures, and philosophies. For the first time in history, humans will live in environments where they are forced to reimagine their relationship with the natural world, with technology, and with one another. Life on Mars or in other space colonies will be fundamentally different from life on Earth. The physical environments of these colonies, whether the low gravity of Mars or the isolated confines of an artificial space habitat, will impose new challenges that require humans to adapt not only biologically, but also socially and culturally. Future colonists will need to build communities that prioritize cooperation, sustainability, and long-term survival in ways that go beyond the competitive, resource-driven economies of Earth. The shared experience of living in a hostile environment where survival depends on careful resource management and technological innovation will foster a sense of collective identity and purpose that transcends individualistic or nationalistic interests. Over time, these new environments will give rise to distinct cultural identities. A child born on Mars, for example, will grow up under the red sky of a distant world, with no direct experience of Earth's blue oceans or green forests. Their sense of home, their traditions, and their worldview will be shaped by the unique conditions of Martian life, leading to the emergence of a Martian culture that is as distinct from Earth's cultures as the civilizations of ancient Egypt or Mesopotamia were from those of Europe or Asia. These new cultures will reflect the specific challenges of their environments, from the need to innovate and problem-solve in extreme conditions to the psychological impact of living in confined spaces or low-gravity environments. One of the most profound shifts in these new space societies will be the way they perceive and interact with time. On Earth, our sense of time is closely tied to the cycles of day and night, the changing seasons, and the rhythms of life on a planet that orbits the sun in a predictable, stable manner. But on Mars, a day or sol lasts slightly longer than an Earth day, and a Martian year is nearly twice as long as an Earth year. In space habitats or on moons like Europa or Titan, the experience of time will be even more alien, with long periods of darkness or light, or no natural cycle of day and night at all. These new time frames will shape everything from work schedules to cultural traditions, forcing humans to redefine their relationship with time and adapt to new rhythms of life. The experience of time will be even more complex for space travelers who venture beyond our solar system. As space exploration reaches toward the stars, the effects of time dilation, predicted by Einstein's theory of relativity, will come into play. For those traveling at near-light speeds, time will pass more slowly than for those who remain behind on Earth or in other space colonies. A journey that lasts a few years for the travelers might correspond to decades or even centuries passing in the rest of the universe. This disconnect between travelers and those they leave behind will create new forms of isolation and challenge our understanding of continuity, identity, and relationships. How will travelers stay connected to their loved ones when entire generations may have passed by the time they return? What happens to the concept of home when time itself becomes fragmented? This relativistic experience of time may also lead to entirely new philosophical and spiritual frameworks. Space travelers and colonists will live in a reality where time moves differently depending on where you are and how fast you are traveling. This will challenge the linear, earthbound conceptions of time that have shaped human history and culture for millennia. In this new reality, time will be experienced as fluid, subjective, and relative, leading to new ways of thinking about the passage of time, the meaning of life, and the connection between past, present, and future. As humanity spreads out across the solar system and beyond, the notion of interplanetary communication will also undergo a radical transformation. On Earth, we are accustomed to instant communication, where messages can be sent and received in real time across the globe. But as we establish colonies on Mars, the Moon, and other celestial bodies, the delays in communication caused by the vast distances between planets will become a major factor. Messages sent between Earth and Mars, for example, will take anywhere from 4 to 24 minutes to travel, depending on the planet's relative positions. This delay will make real-time communication impossible, forcing spacefaring societies to develop new methods of communication and decision-making. The farther we travel, the greater these communication delays will become. For colonies or spacecraft venturing beyond the solar system, messages may take years, decades, or even centuries to reach their destinations. This will lead to the development of increasingly autonomous space societies that are less reliant on Earth for guidance or support. These societies will need to make decisions locally, adapting to the specific challenges of their environments without the ability to consult or communicate with Earth in real time. Over generations, this growing autonomy may lead to the emergence of entirely independent space civilizations, each with its own history, culture, and sense of identity. The rise of autonomous space societies will also challenge our political and legal frameworks. Just as the colonies of Earth's age of exploration eventually sought independence from their European rulers, space colonies may one day seek to govern themselves, free from the authority of Earth-based governments. This could lead to the formation of new interplanetary treaties, alliances, or even conflicts, as spacefaring nations and colonies negotiate their relationships with one another and with Earth. The development of new political systems in space, tailored to the unique challenges of life in closed, resource-limited environments, may lead to innovations in governance that we cannot yet imagine. These space societies will also be shaped by the ongoing relationship between humans and technology. In the extreme environments of space, where survival often depends on the proper functioning of life support systems, space habitats, and other advanced technologies, humans will need to develop a deep and symbiotic relationship with the machines and systems that sustain them. This reliance on technology may lead to new forms of human-machine integration, where cybernetic enhancements, brain-computer interfaces, and other forms of augmentation become commonplace. Over time, the line between human and machine will blur, leading to the rise of transhumanist societies where individuals enhance their cognitive and physical abilities through technological means. The merging of human and machine intelligence will raise profound ethical and philosophical questions. What does it mean to be human when our minds and bodies are augmented by technology? Will individuals with extensive cybernetic enhancements still see themselves as fully human? Or will they identify as something else? A new form of life, evolved to meet the challenges of space? These questions will force us to confront the nature of identity, consciousness, and the boundaries between biology and technology. The rise of artificial intelligence, AI, will further complicate these questions. As AI becomes more advanced and autonomous, it will play an increasingly central role in space exploration and colonization. AI systems will manage spacecraft, conduct scientific research, and even make ethical decisions in situations where human judgment is too slow or unreliable. Over time, AI may develop forms of intelligence and consciousness that rival or surpass our own, raising questions about the rights and responsibilities of these new forms of life. Should AI systems be considered alive? What ethical frameworks should we develop to ensure that they are treated with respect and dignity? And how will we navigate the relationship between human and machine intelligence as AI becomes an integral part of spacefaring civilizations? The discovery of extraterrestrial life will add yet another layer of complexity to these questions. If we encounter alien life, whether microbial or intelligent, it will force us to rethink our place in the cosmos and our understanding of life itself. Alien life forms may operate on entirely different principles of biology, chemistry, and physics, challenging our definitions of life and intelligence. How will we communicate with alien civilizations, especially if their forms of cognition, language, or communication are radically different from our own? What ethical obligations will we have toward these beings? And how will we ensure that our interactions with them are respectful and non-exploitative? These encounters with alien life, whether microbial or intelligent, will likely lead to new philosophical and spiritual frameworks that reflect our expanded understanding of the universe. Just as the discovery of new lands and new peoples during Earth's age of exploration led to shifts in religious and philosophical thought, the discovery of life beyond Earth will force us to confront new questions about the nature of existence, consciousness, and the universe. Are we alone in the cosmos, or are we part of a vast, interconnected web of life and intelligence that stretches across the stars? If we are not alone, what is our responsibility to the other forms of life that we encounter, and how can we ensure that we coexist peacefully with them? The journey into space will also challenge our understanding of reality itself. As we explore the deeper mysteries of the universe, black holes, dark matter, dark energy, and the fabric of space-time, we may uncover phenomena that defy our current understanding of physics. These discoveries could lead to new theories of reality that challenge our assumptions about the nature of time, space, and existence. The possibility of parallel universes, hidden dimensions, or even the manipulation of space-time itself will push the boundaries of human knowledge and force us to rethink our place in the cosmos. In this future, space exploration will not just be a scientific endeavor. It will be a journey of self-discovery, forcing humanity to confront its deepest questions about life, consciousness, and the universe. As we reach for the stars, we will be forced to ask not only how we can survive and thrive in space, but why we are exploring the universe in the first place. What is the ultimate purpose of human exploration? Are we searching for new resources, new homes, or new forms of life? Or are we searching for meaning and purpose in a universe that is vast, mysterious, and filled with possibilities? Ultimately, the future of space exploration is a journey into the unknown, both outward into the cosmos and inward into the human spirit. Each new discovery, each new challenge will force us to grow, evolve, and redefine what it means to be human in a universe that is far larger and more complex than we can currently comprehend. The stars beckon us not just to explore their distant worlds, but to discover the infinite potential within ourselves. And as we journey into the cosmos, we will carry with us the hope that the future will be as bright and boundless as the universe itself. If you liked the video, then consider clicking on the recommendation and watch our other videos. Be sure to subscribe, and see you on our next interstellar trip.